Welcome to the first lecture, section 1, lecture 1 of the course on how to build a blockchain using Python. My name again is Betha Hokong and I will be your instructor for this entire course. This course is a very practical one. It's not theoretical. We've done the theoretical one. If you haven't, have a look at our course list on Scholar Online. You will find a course, a free course on blockchain theory, and go through that to learn the theory behind it. And when you come here, you should be ready to get your hands dirty with Python and start building your own blockchain. So we're going to set up our development environment from scratch. And I sort of wanted to do it in a way that it doesn't matter which operating environment you're working from. So I don't want to do this setup for Windows and then do the setup for Apple and do the setup for whatever, So because this course is available to everybody, I want it to be in a way that anybody can do it. And it doesn't matter what operating environment you're working with. So we are going to be developing our blockchain from a VPS machine that is going to be hosted on a cloud. What is a VPS machine hosted on a cloud? Let me show you. If you go to one of the most popular ones with developers, digitalocean.com, okay, I will leave the link in this document that I'm going to make available to everybody that you can download, and you can go through these links later in case you miss one of the links that I'm giving you, or you can just sort of go through this video in slow motion and pause and stop and then copy and paste the link or write it down, okay? Digitalocean.com. They have what they call droplets, and droplets are just sort of VPS machines that they host for you, and they'll give you space that you can work from, and you can install whatever operating system you want on it, and then you can do computing, but they just sort of give you the computer, and it's up to you what you do with it, and that is exactly how we like it, so that we can customize it the way that we want. We'll install the system that we want on it. So you can move over to DigitalOcean, create an account, and then what you want under the product here is what they call a droplet, okay? A scalable virtual machine. So you can start with a smaller one, and then you can get get bigger and bigger as you go along. And it's up to you. So go to there and you need to get what they call a droplet. That is what a VPS machine is. If you're in South Africa and you want a more local one, we have our own, domains.co.za hosting provider, and you can go there and go /VPS, dash hosting. Okay, I also leave the link for you there. And when you get there, this is where you'll find the VPS machines. The cheapest one is 139 rands per month. Okay, so it's going to cost you something to do this because any hosting whatsoever that you do cannot be for free, and you're not going to be able to build this blockchain if you cannot host it, because you won't be able to host it from your personal machine, and you won't see what exactly we are trying to do if you don't do this. So I highly advise you get one of these. Pay the 139 for the month, learn it, and then you can cancel it after you're done with it, and it's up to you. Because what I like about domains is that it's a monthly payment. If you no longer want it, you can just cancel it. Even with DigitalOcean, they're not too fussy. They're not going to make you sign a long contract. You can pay for the month. The month you don't pay, they just cut off your machine, and that's it. So you can actually just pay for 1 month to learn, and if you don't want to continue with it, cancel it at the end of the month. Okay, so these are the steps we're going to follow. The first one is to install Python in your personal machine. You don't need to do this. Okay, maybe you want to do this to test stuff on your own personal machine, but I don't even have Python installed on my personal machine actually, and I write a lot of Python code. I run all my code on virtual machines. So this is not a this is an optional step. Okay, you don't have to install. And for the purposes of this course, we will not be running Python on our personal machines. This is why you'll be able to do this course whether or not you are on a Mac, whatever machine you want, because we will be running the Python code on this VPS, and we will install the same arrangement type of VPS, so everybody will be able to follow along, irrespective of the machine that you're currently working from. Okay, because the VPS machine will be a machine hosted on the cloud by these guys, and we will put in the configurations that we want as we want them, and all of us will be running the same code. Okay, but Atom you must install. Okay, so you need to install Atom. Atom is going to be our code text editor. Okay, so you can go to atom.io, or you can use any other, like if you want to use Microsoft Visual Basic, whatever, that's up to you. You can use anything. You can use Sublime Text. There's a lot of these code processors, but if you want to follow along exactly what I'm doing and you want to see the color codes the way I have it on my screen, which a lot of people like, then definitely go along and install Atom. Go to atom.io. It's very easy to install. You just download it and it will sense your machine and it will work on Windows and Apple the same. And then after you've done that, so all our code will be written on Atom going forward. After you're done with that, we're going to need what they call Git. Okay, you need to install Git. You can go to, I'll also leave the URL. So all these things I'm talking about, I will leave URLs for you so that you can go exactly know where to go to install Git. Okay, so for Git, the URL is github.com, git guides, install Git. And they've got, if you go to this URL, you will see the instructions for installing it on Windows and the instructions for installing it on Mac, Ubuntu. There's all the different, depending on the machine you're working with, it doesn't matter, just get installed on that machine. And then once you're done with that, we are going to purchase a virtual machine. Okay, I've already explained that to you. So please do this. You will need to do this in order to proceed with the course. This is important. Otherwise, if you just want to watch what we're doing and you don't want to actually technically write your code, then that's fine as well. You can actually watch what we're doing and see the code that we're writing. And we will also make the code available for people that are participating in this course at the end of the course. And then the next thing that we'll be doing is to, once you've bought the machine, you have to set it up, okay? And I'm going to leave this URL for you here as well, the Digital Ocean tutorial for setting up your machine. Even though it is a digital, how to set up, where is it? Initial droplet configuration. Even though this is written for Digital Ocean, if you had decided to buy your machine on domains and not on Digital Ocean, you can actually follow the same instructions, because once you have a VPS, it's actually quite similar how they work at the end, so you will figure it out either way. You can use the same guide irrespective of where you bought it, because I love the tutorial. Sorry, I'm on the wrong place. I love the tutorials on Digital Oceans because I find they're some of the best in the industry because they write them so well. You can see that they're written by professionals. And even when I use a droplet or a VPS that's not on Digital Ocean and I want to figure out how to do something, sometimes I will search. And then I will search Digital Ocean and I'll follow the Digital Ocean tutorial. And most of them work almost every time. So set up your droplet. You want to set it up for SSH. This is very, very important. And if you follow this setup, you will see at the end, they do talk about how to set it up for SSH. So you'll need to get like your SSH keys, and they're very, very detailed. I won't go through this with you, but I assure you, if you follow this tutorial, it's really easy how to do this. Create and upload your SSH keys and do the generation of the keys. This is important. Do all of that because we are going to be SSHing into our droplet or our VPS and writing code on our personal machine and just pushing it to the droplet using SSH. So you must have it configured for SSH. If you're struggling and you've bought it and you're struggling with this tutorial, please let me know. Drop me an email, admin@scholar.online, and I will help you along how to do this, because you have to get this to work before you can follow the rest of the tutorial, as we will be writing our code on our personal machine, but we'll be running it on the VPS, and the way we will transfer the code to the VPS will be through SSH. So your SSH must be working, okay? Then after that, we will install Git in the droplet. So you will configure the droplet for SSH, and after that we will install Git. So I will also share this link with you. It's here. You will see on this document. We will show you how to install Git, because we need Git both on our personal machine and on the droplet. So this first part is when you install Git on your personal machine, and then the second part is when you install Git on the droplet itself. So you need it both ways, because you need the Git to send the files from your personal machine, and you need the Git on the droplet, or a repository on the droplet, a Git repository to accept the files. And you'll see how it works. It's really amazing. It's like quite ingenious how it all works and it all comes together. So you need Git on both sides. And then after that, you need to install Python in the droplet. Remember I said this is optional and we won't even run any Python code on our machine. So you don't even have to do this, but you must install Python in the droplet or the VPS machine that you have purchased. And I also have another link, which I will link here as well. So depending on the setup that you have, you can install. But I recommend, if you are doing following along, I actually recommend that you do Python. You'll see which machine you're using, and you maybe probably want to know, should you do 20, 18, or 16? I think anything between 18 and 16 should be all right. But let me actually be specific to figure out which one did I use. Let me just remember, I'm going to pause this video here so that I can tell you exactly which Python you must install and which Ubuntu server you must use, okay, because it's going to be important. Some of the things don't work with different versions. So I will pause this here and then I will continue so I can give you a direct answer. Okay, so I've just confirmed it. The Ubuntu server that you need to install is the 18.04. Probably the other ones will work as well, but just so that you don't have issues, because sometimes small details don't work, okay? So click on this one, and I'll just copy this link here and put it on the document as well. So instead of these collections, I'll just put, okay, I leave the collections. No, let me just take it out so you don't get confused, okay? So rather use this one, the Ubuntu 18.04. So when you go and you buy your digital machine on Digital Ocean, you will click Droplet and you will create an account. But so I can't go and create an account, but after you've created an account, they will show you multiple operating servers that you can install. So you can install CentOS, you can install Ubuntu, you can install even Ubuntu 16, you can install whichever version of Ubuntu, but keep in mind, because now we're working with 18.04, try to install 18.04 Ubuntu as well, or even if you do this as well, they also give you options on here as well, the different type of operating systems you can install. Try and do the one that I'm doing so that everything will work the same. The other ones will most likely work, but I've noticed there are some certain things that are different here and there, and if you don't want to have issues, just do as I do. And I was just double checking. This is my virtual machine, and I was just double checking that I have Ubuntu 18, and the code that I'm running, that I'm going to tell you, I've tested it on Ubuntu 18, so I know I'm not going to have issues with Ubuntu 18 and Python 3. Okay, so you also want the Python version that you want is Python 3. So this tutorial, just as it is, just follow this along, but make sure that when the first installation that you do, you pick Ubuntu 18. Okay. So once you're done with that, you'll be ready to go. You'll have a virtual machine that you can SSH into. Okay, that virtual machine has got Git installed in it, all right, and Python installed in it. Okay, and then you are ready to go. So the next part of our setup will be us setting up our file structure system. All right, and I will do that on Atom, and then I will show you now how to link the current code to the code on your Ubuntu machine so that they are talking to each other. So the first part is just to get the environment ready, but the second part of the setup is just to set up our code, and that's what we're going to start with now. Let us start by creating the file structure that we're going to be working with for this entire project. So you need to go to the directory where you'll be working from. So I'm working on the same document, I've just added more information, and I'll make all of this available to you. You need to create a folder directory, and we're going to call it Python blockchain. So just name it what I name it so that you don't get confused later on in the course. And then under that directory, we're going to add the following files: app.py, config.py, blockchain.py, wallet.py, psserver.py, getignore.py. Name it exactly the way I've named it. That's why I've written it down, because later on when we're referring to these files, if you've given it a different name and you're following along, you don't want to have problems. So create it the way I've done it. So if you go to your terminal, so let's work everything from the terminal. You should be able to access terminal from Windows and from Mac the same way. Okay, so if you go to your terminal, you'll start at the root of your computer. I mean, at the beginning of your computer under your your file. Then you just navigate to where you want to create this directory. So I have a folder called development in my side, so CD development. I want to create everything in here under CD development, and I want to make a new directory. And you know how it works with the terminal, you just say mkdir. This will make for you a new directory, and I'm going to call this directory Scolo courses. Okay, and then I want to at the same time move into that directory. Okay, So what this code is doing is that it's creating MK directory called Scholar Courses, and then it's going to move me to that directory. Then you will see that I'm now in that directory, Scholar Courses. Then when I'm in here, I'm going to make a new directory that is called, remember what I said, you must call a directory. Please call it Python blockchain. You can just copy and paste that in there. All right. Python blockchain and CD into that directory. Okay. CD into the same directory. And then you should now find yourself in the directory called Python blockchain. And once you're in this directory, everything we're going to do in this directory. And we're going to create all these folders in here, app.py and all of this. So the way you do it on the terminal, you just say touch app.py, leave a space, and do the other ones, config.py, blockchain.py, wallet.py, peerserver.py, and I have .gitignore. Okay, let me just check my spellings. app.py, config.py, blockchain.py, wallet.py, peerserver.py, .gitignore. All right, and just create all of those. And then if you click ls to list everything in your directory, you'll see all the files you've just created are now available here. And then we're going to open Atom from this place so that we can see all these files from our development, from our text editor. And the way you do that is you just click atom dot, and if you've installed it correctly and you've linked your everything, you shouldn't have an issue to do this. Atom dot, it will open Atom, but it will open it in the directory because you've used the dot sign. And then you will see your Atom file now. You can see your app.py. This is where we're going to write all our code for the app. This is where we're going to write our blockchain code. This is where we're going to put our config file, our peer server code, and our wallet code is going to be written in here. I'm just going to put this in a different desktop. So now I'm happy with this. And so that first step of creating the directory is done. And then once we've done that, we're going to initiate Git, because currently we don't have Git initiated in this. And the way you do that, if you've installed Git correctly, you should be able to just say Git init, all right, just like that, and it will say initialize empty Git repository in that, and that's all you want to do, okay? And then once you've initiated Git, you're going to leave this, and the rest of the things we're going to do somewhere else, but we'll come back to this. So this is a tab that's opened on the terminal, okay? So that first part is done, and this is what you're doing on your personal computer. The rest we're going to do on the virtual machine, okay? So let's go over to the virtual machine. If you've bought it and installed it correctly, you have SSH to your virtual machine, you should be able to access it on your device and SSH to the user that you created. Remember, when you create the virtual machine, you have the root user, and then you have the personal. You need to create a new user. And if you followed my tutorial, you follow the tutorial that I've linked for you here, this tutorial to initiate your Git machine on Digital Ocean, they will show you how to create a new user that has sudo privileges, okay? You don't want to work on the machine as root. You want to create a new user with sudo privileges, and then you log in as that user, okay? So I've now SSH'd as the new user who has sudo privileges. This is where we are going to be working from. And now we are at the root, or at the beginning of this. This is now the virtual machine. You see the color is even different. Here, everything I'm doing here, I'm typing, I'm running this code on my personal computer. But once I SSH into the virtual machine, I'm running this code in the VPS that I've just bought. This Ubuntu VPS is where I'm running this code. This code is not running on my personal computer. You'll see I've got two tabs. This is one tab, there's another tab. So you can just open a new tab and do the VPS work on a different tab, and your personal work on one tab. Now on this second tab, what you're going to do is you want to also CD. I've got a folder called development. I'm going to CD into that folder, and it will show you you're in the development folder. Let me just see what's in here. There's nothing in here. So I'm going to make a new directory in here, and I'm going to call this the directory that we want to work with here is, we want to call this Python blockchain. Okay. Create new folders called Python blockchain. Okay. So before you do this, create Python blockchain. Okay. And as you can see, I'm using just one word for simplicity, and I'm not gonna leave any spaces. I'm not gonna leave any. I'm not gonna use capital in the middle because Ubuntu is very particular about lowercase and uppercase. For simplicity, I'm just using one word with nothing in it, all small cases. Okay, so I'm making a directory called Python blockchain. You can call this whatever you want, but if you want to follow along and not get lost and copy and paste my code, just call it Python blockchain as well. Okay, and cd into it. And okay, you need two ends, and cd into the same directory. Okay, now we are in the development Python blockchain directory. So once you're here is where you need to make directory. So you need to mkdir Python blockchain, and then you need to mkdir this and that. So mkdir and cd. Okay, so mkdir Python blockchain and cd Python blockchain. Okay, so this one makes the directory, and then the cd moves you into the directory. Once you've done that, you want to mkdir Python blockchain and repo. So I'm just gonna copy this command and put it in there. What this one does, it creates two new directories. The first directory will be Python blockchain that it will create. The second one, it will be repo. So we will have two directories, one called Python blockchain, the other one called repo. This repo is what we will use for the Git repository when we communicate between our personal computer and the repo itself. Okay, so do that, and then you have two directories. If you ls to list what you have in here, you will see you have two directories, Python blockchain, and the second one is repo. Okay, so we are going to work with both these. So the first thing we're going to do is cd to the Python blockchain one. No, so I'm pasting the wrong thing. So let's cd into this one. Okay, let's just copy that. There's nothing there. All right, so we're just gonna ls to make sure you see there's nothing in there. We're just gonna git init bay, and you have followed my instructions, and you have already installed git in the droplet. Okay, so when you click git init, not click init bay, just click init, git init. Okay, it should initialize an empty git repository under your Python blockchain folder or directory. Okay, so I've git init. Yes, there you go. Initialize empty git repository in here. That's all right. Then you're gonna just cd dash dash and leave this, and now we have gone back up. And if you list again, you are under Python blockchain and repo repository, and you just want to cd into your repo. Now we're gonna do what we're gonna do in the repo. So I've already run this command. I've cd into here. So I'm gonna replace all these xxx's with the file name there. Okay, so you've cd in there and you've git in it. Okay, after you do that, you need to cd minus to get out of the repository, and then cd repo, and now we are cd repo. We've done that. After you've cd repo, we are going to do git init bay inside the repo. So git init bay must happen inside of the repo. I'm gonna paste that instead of the repo, git init bay, and then it's going to say initialized empty git repository. Okay, but it's a bay one under repo. All right, so this git init is different from git init bay. Okay, so just follow these instructions here and watch this video so you don't get this wrong. After you've done that, we need to sort out the hooks, okay, so that we can be able to send our files in here. So under the repo, after you have initialized the git repository, you need to run this command sudo. That's why you need sudo privileges for this user. Sudo nano hooks post receive, and it's going to open. The moment you click the word nano, you are opening the nano a text editor, which works on Ubuntu, and this comes with Ubuntu. You don't have to install nano yourself. You don't just run the command the way I run it, and because it's a sudo command, it will ask you to enter your password, and that's what we're going to do now. You won't actually see the password as you're entering it, but if it's correct, it's going to open a nano file. So this is actually a text editor, a nano text editor inside of your Ubuntu machine, and we're going to write some code in here that will handle the hooks when we send files through here. And the what you need to write in there is this, and I'm going to make it available for you, and I'll explain to you what this does. Okay, bin bash, it's running a bin bash command. Okay, and then it's going to find the work tree. Okay, and you need to make sure that you get this directory, the routing correct. Okay, home is it takes everyone back to like the sort of the root of the computer, and then Zatosh is the user, so this is my username. So you will replace this with whatever username you're using on your VPS. Okay, if your username is whatever name you've decided, Paul, Peter, Mary, replace this Zatosh with your username. And then under the username, the first folder we had was the development folder. Okay, and under the development folder, I created this file called Python blockchain under the development folder. Okay, so it's going to go to the development folder and look for Python blockchain, and then it's going to look for Python blockchain again. Okay, and then after that, there's no spaces. Okay, so no spaces. Let's just make sure. Right. So copy that and put that as well there as well. Okay, so it's gonna go to your the home. It's gonna go to the user. It's gonna go to the development folder, Python blockchain, and it's gonna look in there. That's where it's gonna put all the files that is gonna be sent. Okay, and the repo for it will be the home Zatosh development. Okay, Python blockchain repo. Okay, and I'm gonna show you this again. Let me just actually exit this. To exit this file, just click X. Okay, it shows you there. So Control X, and it exits the file. I'm just gonna CD to the root to show you how I got here. So when you're in the root of your computer, all right, this is under the username, whatever the username you selected. All right, so this is birth. In my case, Zatosh is my username. You'll see Zatosh at the machine. So from the root, you need to CD development, and you can use whatever root you want. This is the root that I've selected. CD development, okay, and under development you CD Python blockchain, okay, and you CD Python blockchain. Okay, so this is why I've written it like that. Home Zatosh development, Python blockchain. And this is where it's going to put all the files. Currently, there's nothing here, but once this command is run, all the files that we're sending to the Git repo will be added here. Okay, and if you CD back to the repo itself, the repo is under home Zatosh development Python blockchain repo. So now we are home development Python blockchain. There should be repo and Python blockchain here. If you CD repo, this is where you will be, and this is where the repository is. Now, where the repository is where we are running this nanohooks post receive, and we are going to open the file that is called hooks post receive, and in here is where we are going to write this code that will then work to make sure that we get okay. So we're just gonna copy this code as it is, all right, and we're gonna paste it there. Okay, so what this code done is a bin bash code. Is gonna get the work tree is home Zatosh development, Python blockchain, git directory, home Zatosh development, Python blockchain repo checkout. All right, so just save that. It will ask you if you want to save the changes. Say yes, you want to save the changes. You have sudo because you open the file as a sudo user, therefore you have the permission to do that, and then that will be saved. And as soon as you finish saving this file, you need to run this command chmod hooks post receive. This is important. If you don't run this command, nothing will work. And then when you're done running this command, we can go back to here where we see both our files, Python blockchain and repo. And then our work this side is done. We're going to go back to our folder and add a sort of what we call a like a git at a remote origin. Okay, so to do that, we need to add, this is not the IP address, this is not my IP address. Okay, so I need to find my IP address. So what you need to do is run a command that says git remote at origin root, okay, at your IP address. This is the IP address of the VPS, so you need to find the IP address of this VPS. Okay, and after you've added that IP address, you're gonna say home Zatosh development, and this must be Python blockchain.repo. Okay, This must be Python blockchain.repo. So what this does is that it adds for you an origin, a remote origin on your current computer, a remote repo. Yeah, I'm sort of stumbling on my own words. But basically, in short definition is that it allows you to now send all the sort of Git everything that you would do on this computer. It allows you to take these files and send them directly to your VPS using Git. Basically, in short, that's what it does. Okay, so you need to copy this code here. Okay, Git remote at origin. Okay, and put it there. And this only works if you have already initiated a Git. You already done Git init, and then you do this. I'm not going to enter this now because my this is wrong. The IP is wrong. This is the wrong IP. So I'm going to go find the IP for my VPS, and then I'm going to come back and enter that. Right. So I have just pasted the IP, the correct IP address, and just to double check the spelling again, it will go to the home, to the user Zatosh development, and you look for this repo, and then that is the origin that it will add. Okay, remote origin, and then you just click enter. You won't see anything, but it's done. And to test it, okay, you need to start adding something to your Git. So Git add, all right, and then Git commit, create a commit. Let's just call this initial commit, all right, and you will see it's adding all the new files that you've added to your Git repo, all right, and you'll see it including the git ignore, but I haven't put anything in the git ignore file for now, but I will add it later. It's fine. Then once you do that, you need to git push origin master. Okay, this is a very powerful command. This is the command that pushes your Git repo, everything you're doing in Git here, and it pushes it to this repo over here, which will then go into the hooks post receive and add your files to that folder. Okay, so you do that, you click enter. It's gonna go and look for the origin, and then it finds the SSH key. It will find your private key, and then you'll have to log into the SSH because you are SSHing into your machine. And this only works if you have created the SSH keys and you follow the tutorial the way I've showed you. If you've done that, this is not going to be a problem. This is going to work. Actually, I haven't showed you. I just gave you the tutorial to follow this one here, okay? Provided you follow that tutorial properly, this is going to work. And then what you do here, you just put in your, because I've added another additional password to my SSH. If you haven't added a password, it's not even going to ask for it, okay? And then once you're done, it created a new branch called master. And then we're going to go here to test if it has worked. If it has worked, we should be able to cd to this folder, okay? And when we list this folder, we should be able to find the new files. app.py, there wasn't anything here before. These files we created over there, all right? And we added them into Git over there, all right? And now on our virtual machine, we've pushed the changes from there to our virtual machine. Now, when we check our virtual machine, the files are there, okay? So this is how we're going to work. We're going to work off our current machine, which is here. We're gonna do all the work in our private current machine where we're working from home. And then when we finish, we push the changes to our virtual machine, and the virtual machine is gonna pick it up, and we're gonna run the code on the virtual machine. So this is gonna allow us to do this entire project without actually installing Python in our machine, because I have so many things installed in my personal machine. I don't want to install, for every project I do, I cannot run everything on my personal machine. My personal machine would not have enough space to do that, though. This is really an amazing way to get code running and testing it on the virtual machine. So now we have completed the setup. At the end of this, we have your virtual machine set up, connect to the current machine, and Python, everything running. And now we're going to start writing the code and developing our blockchain. Now we're ready to get our hands dirty. Welcome back to the course. My name is Betha Khokong, and I will be your instructor on this Python blockchain course, where we're going to be building our own blockchain using Python from scratch. And the whole point of this exercise is to get you to understand the real fundamentals behind blockchain. This is a better way of understanding how a blockchain works, is to build it yourself. So let's get our hands dirty. From the previous lectures, you should now have your own you should be sitting on your own directory. This is where we're going to be building our blockchain. If we list this, you can see all the files that we've created in here. And then you should have a second tab open that is connected to your virtual machine, which is where we'll be running our Python program, because we're not running it in the same place where we are. Unless if you want to run it where you are, you can install Python there. It's really up to you how you do it. But if you are following along, you would have these two tabs open. Then you would have Atom open to the files. These are the same files that are in your directory, and we're going to start working on this blockchain.py file. And then after that, if you remember from, if you did the introductory course, this is what we're going to be building in this course. We're going to be building a blockchain already. So we'll have the first block, the second block, and we're going to add some data to it. And we're going to take basically what is written here, and we're going to turn it into code, and I'm going to demonstrate to you how to do that. Okay. Before we get started, we need to do a couple more things on our virtual machine to get it ready. We need to install our virtual environment where we shall be running our Python program from. Okay, and for that, I'm going to attach this in the course handouts. Just to list down the steps that we're going to follow and the sort of the instructions we're going to run on the code. I mean on the shell. The first one is we just want to update everything. So just copy that sudo update and just enter that in there, and it's going to just run, and it will require your sudo password. You will just enter it, and then it's going to run some updates in there. Okay. Then after it's finished running this, you are going to run this second command. Okay. This command is going to install Python 3 pip. Okay. It's going to install the development tools for Python. There's a couple of things that are in here, and if you're following along, just copy this line as it is, and I will put this document for you to have and be able to copy all of this, because you have to install it like it is here so that you don't miss anything. Okay, there's a couple of Python development tools and setup tools and Python pip and all this that you will need to build your virtual environment so that you can work with. Okay, so I'm just going to enter there and say yes, and it's gonna just install all of that for me. Okay, while it's doing that, I'm going to go back and get the next line. So this is where we install our Python 3 virtual environment. Okay, so we are going to be working off Python 3. If you did the last lecture, when you're installing Python in the last lecture, make sure you have installed Python 3, because we're going to install Python 3 virtual environment. If you are working with Python 2, the process is slightly different. Okay, so for Python 3, this is what we need. So I'm just going to copy that and come back here, and I see it has finished installing that, and then I'm going to copy that there and just click yes. Okay, and we still have, it looks like we've got an error with dpkg. I hope that's not going to affect us a whole lot. Okay, so we have installed our Python environment with one minor error. I'll investigate that. But after that, after installing our virtual environment, now what we need to do is to actually initiate it, okay, or create one. So we have this line as well. Just copy it as it is, and let's just clear so we can see what we're doing. All right, and then I'm gonna paste that line over there. So what this is doing, it's now going to create a new virtual environment inside the directory. So when you run this command, run it inside the directory where you're going to be working from. So it's in our case, development Python blockchain, and we're gonna call our virtual environment blockchain ENV. Okay, so the blockchain ENV is going to be a folder that will be our virtual environment. So all the Python libraries that we're going to install are going to be installed in there, and this is the one that we're going to be working with. You can separate, you can build different Python environments for different Python programs, and they don't all affect each other. Okay. So let's do that and wait for that to run. So it has run. We're just going to list everything in the directory, and then if everything went well, you should now see a new folder called blockchain ENV that was just installed now with that command there, and all our sort of pip installations are going to run in there. And then after we've done that, the last command we need to run is to activate that environment. Okay, so I'm just going to copy this as well. Source blockchain ENV being activate, and then I'm going to go back to my shell there, and I'm going to type it and I'll explain what this does. It just goes into the blockchain ENV and looks under the bin, and then it'll activate the ENV. All right, so just click enter, and if everything goes well, you should now see the ENV activated on your command prompt. It wasn't there before, now it's there. So everything we're doing now, we are doing inside the environment. Installing the libraries we'll be using, even running the program, we are running it now inside the environment. So this is the best practice in running a Python program. You don't have to use virtual environment running a program. When I started a long time ago running Python, I used to just install Python, install pip, and then install all the stuff, and everything would be installed in my whole computer. Okay, and then I want to run a Python program using Python 2, not Python 3, and then everything is all mixed up and it's just a mess. So the best way to do this is when you're running a Python program is to get a Python environment for that Python program, so that all the Python libraries that you are installing for that program are sitting in the virtual environment, and then they are only applicable. So the virtual environment is like a little container, and everything is going to run in there in that little room. Okay, and as soon as you exit the virtual environment, you've exited it, and that's how it works with JavaScript. When you do a lot of the JavaScript type applications, they do it like that, but with Python you have to actually manually do the environment and install it from there. Now what we're going to do is we're going to start installing the libraries that we'll be using, and I want to just install them all at once at the beginning, and I'll explain them as I go along, as I'm using them, because I've done this before. I know all the libraries I will need, so I'm going to just try and install all of them one. But the important one is this one. This one is not connected to the blockchain program we're building. This is just part of the environment. The first thing you should always install after doing this is Wheel, because Wheel is going to help you install all the other things. Okay, then we're going to pip install. And another distinction: once you have installed Python 3 virtual environment, and you've installed it on a Python 3 Python, when you get inside the Python, you don't have to use pip3, because if you were running a Python program not inside a virtual environment, and you had both Python 2 and Python 3 running, you would have to always refer which Python you're talking about. You'd always have to pip or pip3 depending on which Python you're installing it for. But with the virtual environment, the nice thing about it, we've already specified that we are installing virtual environment for Python 3. You will see on what we did there. This is already telling us that this is already installing this virtual environment inside of Python 3. Now, when we run pip, we don't have to say pip3. We can just run pip, okay? Because now because we're already in that virtual environment for Python 3, it's already like pretty much it's obvious that we're doing pip3, but we're doing just pip. So in here, you'll just say pip install. There's a couple of things we need to install. We need to install Flask. Flask is the app framework that we're going to be using. Okay, we'll use it a bit later, not yet, but just install it now so that we have it. We're going to use request as well later on. We're going to use UID. We're going to use ZMQ. We're going to use something they call fast EC DSA. Okay, I hope I got it wrong. This is fast elliptic. This is the elliptic cryptography stuff. Okay, this is the cryptography stuff. Fast ECDSA, and then we need to I think threading as well. I'm not sure if we actually have to install this. We're going to use SQL database, but because we're working off of Flask, we can just install the Flask MySQL. I think that's it. Okay, so threading you don't have to install. Okay. So let's see what's been installed. Flask has been installed. Requests has been installed. UUID has been installed. ZMQ has been installed. Fast DCA has been installed. And then I haven't seen Flask MySQL, so let's do that. Pip install Flask MySQL. Yes. No, sorry. I spelled it wrong. Pip install Flask MySQL, like that. Okay, perfect. Then let's I don't know if we have to install this or if this is also included. Okay, no, pip install. Okay, I think that's it. So we have everything that we need. We will be able to run a simple program in here, and I'm going to just demonstrate to you quickly how this works. Okay, so in here I'm going to, let's try one of the let's import. So we can import everything we've installed, even though we haven't installed it in this computer, we installed it in that computer. We're not going to be running it in this computer, we're going to be running it in that computer. So we can import all of these things. But I just want to test quickly, okay? Let's say pip install UUID, okay? All right, and then I'm going to say then the random is equals to UUID 4. All right, and then I'm going to say print random. Okay, it's just a quick test function. I'm trying to invoke this thing that I've imported and UUID 4, and then I'm going to try and print it out. So I just want to show you how all of this works. So I'm going to, first of all, file, I'm going to save this, okay? And then the first thing we do is that we add it to Git, and then we push it to the other side, okay? So we'll do git add, git commit, and then we need to git push. Okay, there's this misspelling there, okay? Git commit. All right, and you can see the stuff has changed, and then we're going to push it. Remember, you've already set the origin master, so we're just pushing it directly to our virtual machine. We set it up in the previous lecture. All right, you need to enter your password for root. And then on this side, now we've pushed it. This is currently here. If we say py, and if we say ls, and we say nano, I just want to open the file to show you that this file now actually will have, where did we make these changes? In blockchain.py. So I just want to open blockchain.py. If you say nano blockchain.py, nano is the text editor from the Ubuntu side. Nano.py, it opens up that document. This is what we just typed in here. So inside that file, this is what we've typed, and then I'm going to close it. And then after we've closed it, we're just going to run it. And the way to run that Python program is just type Python. Okay, again, you don't have to say Python 3. You can just say Python and app.py. Okay. Okay, sorry. Python, not app.py, blockchain.py. I'm running the wrong function. Blockchain.py. Okay. So it's going to run. So it printed it. So it imported UID, it created random, and then it printed random, and the random that it printed is that. Okay. If we do this again and we run this function again, it's going to print a different random, and every time it's getting a different random value. Okay, so now we know that our sort of setup works, that we can write code here, we can push it over there, and then we can run it from our Ubuntu machine. Okay, this is what we're going to be doing all the way going forward. So let's get into our blockchain. Okay, I'm going to import everything that um, that I've sort of bought. Import. Okay, finished importing everything. When you finish doing this, and I've done the test offline, and I realized some of the things were not properly installed on the other side. So what I suggest you do, you copy what I have here. Okay, you can pause this video, freeze it here, and just copy everything that I've got here and paste it on your own Python program. Do what I did, push everything to this side, and then just run the program. Run Python blockchain.py from this side, and then just make sure you don't get any errors, because some of the things didn't install properly. Like, I think it skipped, some of the things that I was trying to install, all of them at the same time, and then it will say something like no module named UUID. It means UID was not properly installed. So just go back. When it says no module named this and that, you just say pip install that thing, and then no module named fast ECDSA. That also didn't install properly. Then you just say pip install that thing. Pip installs this, and you actually had to install the majority of them again from scratch. And then another thing I learned, pip install flask MySQL. Okay, there is flask MySQL, and then there is flask MySQL DB. Right? I tried to install Flask MySQL, and then I ran this program, and then it gave me an error, no module named Flask MySQL DB. So just rerun it with pip install Flask MySQL DB. Okay, not underscore, like this. Pip install Flask MySQL SQL DB. All right, I've already done it, so you don't have to do that. But in your case, just install everything and then run this program. If it gets error, just keep reinstalling. But I've already done it, so everything is good on my side. So the first thing we're going to do is we're going to create a class. Okay, and that's how you do it in Python. You just say class, and we're going to call this class blockchain. Okay, and then we just put the double colon or semicolon at the end, and we're gonna write all our class functions in here under the class blockchain. So the first function that we want to write is a function that creates a block. All right. So we're going to create a function in Flask. You just use that word, df. That's for a function, and we're going to call this. We'll change the name later, but let's just call it create Genesis block. Okay. All right. So class blockchain dev create Genesis block. And for this, we need a couple of things to create a block, okay? And I'm going to take you back to this, what we did here. So we need to know what is the index number. We need to know what is the timestamp that we're creating this at. We need to know the data that goes into the Genesis block. We need a nonce, and then we're going to have to calculate a hash, and then all of this is going to form our Genesis block. And we're going to create the block using a Flask dictionary, which is like a form of like a data set, that a set of data in one place, and that data set includes all these variables in that data set. So every time you get an instance of a block, every block must have an index, a timestamp, the data, the nonce, and the hash. If you understand object-oriented programming, that is how object-oriented programming works. You have your objects or your classes, and a class can contain functions, but it can also contain data sets, which are like objects. And within this data set, in Python, we call them dictionaries. Within this dictionary, you'll have like a value, pay, like value and product pay, whatever. So each and every block data set or block dictionary will have an index, a timestamp, data, nonce, and you have to define all of these variables for each and every single block. The data inside the variables can change. So the index can be 1 for this block, and it can be 2, can be 100 for another block, but each and every block will have a variable called index, okay? The timestamp can be today, tomorrow, whenever for different blocks, but each and every block will have a variable that is called a timestamp. The data as well can be different, but the data variable must be defined. The nonce must be defined, and the hash must be defined. So we're going to have to create a class. We're going to have to create a dictionary that has all of this, okay? But we're not going to overly complicate this because we don't have a lot of dictionaries in this program that we're going to create. It's just really going to be a dictionary of block, and then everything is going to work with this dictionary. So we're just going to create it in the function as we go along, okay? So we're going to say, because the other way of doing it is to have a different file for dictionaries and create them as objects and then call that object inside your function. But we don't want to overly complicate this. For now, we're just going to do it like manually on the go to just simplify the process for you, okay? Because this blockchain actually is not as hard as it might look, okay? So for now, we're going to say create Genesis block, all right? And then we're going to define all the variables that are going to go into creating this Genesis block. All right. And then we're going to say that a block is equals to a dictionary. Okay. This is the function way of representing a block. We're going to say a block is a dictionary. Okay. And then within this block dictionary, we're going to have different variables, okay? So the first one is the index, okay? So the index for this, the first, the index for the Genesis block, creating the Genesis block is 1. We're gonna start with index 1, okay? And then the next variable that goes in there is going to be the, we've got the index, and then the next thing that we need is the nonce. No, we need the previous hash. Okay, because this is our Genesis block, we're gonna just say our previous hash is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we're gonna give it 10 zeros, whatever it is, just put it like that. It doesn't matter what you define as a previous hash, actually. And then the block nonce, we're gonna give this a random number. So we're gonna call this 456. Doesn't matter. Okay, and then we will get back to this later. Okay, the block data. We're going to say this is the data, the information. It would be the transactions. It could be anything. This is the information that is going to be stored inside of the block. So in our case, I'm just going to pick a string and call this string, this is the Genesis block of Scolo Online Python blockchain. Okay, so this is a representation of a string. How you represent a string in Python, you will just type everything inside inverted commas. Okay, then that represents a string. If it's a number, you will just type it as it is, and Python knows it's a number. This is why I love Python, and the difference between Python and a lot of programming languages. In a lot of programming languages, especially Java, you have to define that this is a string. This is a number, this is a long number, this is a short number. Python is just, you just write it, and Python just knows, okay, this must be a number, this must be a string. And so Python is one of the most intuitive languages. You can almost think your way as you're writing the code and sort of create your logic as you go along, and just type it as you would think it in your head. And then it just, the Python language is really easy to work with that way. The only thing you have to remember in Python that they're very strict on, and maybe I must mention this at the beginning, is your indentation, like the spaces you have from the beginning of your, like when you write a class blockchain and you type enter, you have to then like leave 4 spaces before you write def, and so forth and so forth. This, what we call Atom, that I'm using, the Atom code editor that I'm using does this for me automatically. But if, for example, your code editor did not do the indentation for you, you would have to sort of count them yourself and make sure that you don't get that wrong, because Python is very strict on it. So you have to get that right, okay? So the block data, that's what the block data is. We need the block timestamp, all right? Okay, so to get the block timestamp, we need to calculate that block timestamp, all right? So we have imported what we call a datetime, okay? So we're gonna calculate our timestamp quickly, okay? And I'm going to call this variable, I'm just gonna create a variable and I'm gonna call it the time. And the way you do that, you would say this datetime, okay? dot datetime. Okay, datetime dot datetime twice. Okay, and then you say now, right? That's if you imported it like that. A faster way of doing it is to not import it like this and say from datetime import datetime. Okay, so already if you do it like that, saying from datetime import datetime, it already included one datetime, so you can remove the one datetime out and just have the time is datetime dot now. And then this is going to be like a datetime object. Okay, so you need to convert it into a string so that you can put the string into your timestamp. Okay, and I have it in here somewhere. I've put my notes here because I don't want to forget. Okay, so the format especially. So the timestamp will be the time times strip time. So this is just a function that converts your date time object, which is this one here, into a string, and then you define how to show that string. Okay, and then now it can go into the block as a string. And then after that, I'm going to so we have the index, we have the nonce, we have the hash, we have the previous hash. Okay, we don't have the current hash. Okay, we don't have that. We're going to calculate that later. We have the previous hash, we have the timestamp, we have the data. Now we have to calculate the temp and for the hash, the current hash. All right. So to get the current hash, I think I've got it in there. Okay, encoded block. So you have to first of all encode the block that you currently have, and then after that you can calculate the hash. So let's do that. Okay. The encoded block, I'm going to just copy that in here, and then I will explain to you what this does first. Okay, so we take this block as it is. It's currently a dictionary object, and if you understand in Python, dictionaries are not always ordered. They're like unordered objects, you know. So it can like decide how it wants to order it itself. And when it comes to hashing things and hash hash functions, you need to understand that even if you just like put a comma in the wrong place, the hash changes. So for us to not have errors and issues with the way we're going to be hashing our objects, we always have to order the dictionary. That's why we have this sort keys true. Before you hash any object, we are going to sort the keys out so that it's sorted in a specific order. And it will always be sorted in the same order every time, because once you hash it, if the order changes and you hash it again, it will give you a different hash signature. Even though the data is the same, if it's ordered differently, the hash will be different. So for us not to get errors with our blockchain, because the hash function is very sensitive, I mean, even if you put a comma in the wrong place, the hash will be different. We have to order the block. So this is what the encoding does. Okay, not what the encoding does, but before we encode it, we sort the keys of the block. So we take that block function and we sort the keys, right? And then after we do that, we encode it. But before we encode it, we JSON dumps, which means we now, sort of this function of creating like a string from the JSON, from the Python library. And let's just make sure that I've got JSON imported. Yes, I've got it imported. So we're using that to sort of create a string from the Python dictionary, and then we take that and we encode it, and now we have an encoded block. And then this is what we are going to hash. Okay, so we go back to this function, and then we're going to use the hash library, okay, to hash it. And I will explain to you what this does as well. Okay, so the hash so I'm going to call this the new hash. The new hash is we're using the hash library. We're using the SHA-256. So this is the 256-bit encryption. If you recall, we discussed this when we're doing the introductory course, that our data is, the signature is on 256-bit sort of signature encryption, but also the hashing is the same. Okay, this is the level that we use, that is used in a lot of the blockchains. You can change this encryption to anything that you want. We have just decided to use the 256-bit encryption. And then we use the encoded block. That's the one that we create the hash for. And then we use hex digest, because that just sort of displays it in a format that we are going to be able to read. Otherwise, it's going to show it like a 256-bit number, which is not going to make a lot of sense to you. So it takes that number and it sort of represents it in a hex format, okay, so that you can be able to read the number clearly with like few digits on it, okay. So once you've done all of this, we now have we have created our Genesis block, and our Genesis block has a new hash, okay. And then what I'm going to do, I'm going to just say block new hash, okay. I'm gonna say block new hash is equals to new hash. All right, and then after this, I'm just going to say print the block. Okay, so I just want you to see what the block looks like. All right, and then we're gonna try and see if we've been successful with this function and if we don't have errors. Okay, and so when I write my code, I like to sort of write one line at a time, test it, and I build upon it, code line by line or function by function, as it becomes more and more complex. So we're going to take this from just one block, and as we build our blockchain function, we're going to be testing it, as we go along, and we're going to see what is going to be created there. So I've said print block. So for us to be able to test this function, we have to actually run it. Okay, so we have to say, we have to call or invoke our class. So we're going to call it blockchain. All right, and blockchain is equals to blockchain. So what we're doing here is that we're just calling the blockchain function, and then the blockchain class, and then we are calling it, we are putting it under this variable blockchain. All right, and then after we've done that, we're just going to run the function create Genesis block. And then so for us to do that, we say blockchain dot create Genesis block, like that. And then what this will do is that it will run this function create Genesis block, and at the end of this function it should print for us the Genesis block so we can see it for our blockchain. Okay, so let's save this, let's push this. Right, okay, so let's see our functions here. Let's open it up, nano blockchain.py. Let's have a look at what's in there. There you go. So everything we've written, it's in here. All right, so I'm not always going to check, but a couple of first time maybe you can do that. And then we're just gonna say Python blockchain.py to see. Oh yes, okay, yeah, I know what this is. Okay, so yeah, so we're gonna fix this because we need to say self in here before we can continue. Okay, so what you need to do to correct that error is under the function that you've create Genesis block, you just need to add the word self. Okay, it's just the way Python works, and I just forgot to do that. Doesn't really mean anything, but you have to do it not to get the error. So I've added that, and then you're gonna push everything. I've already done that. Then let's go back and run the function. Okay, I've run it to test it. So when you run it, you're gonna see your first block. So it's printing for us index 1. The previous hash is this zeros. The nonce is 456. The data is, this is the Genesis block of Wara Wara. The timestamp is 23rd of October, and this is the exact time that it's recording this on. And then the new hash, this is the hash. The new hash is this number here, all the way from the this is the new hash that it prints for you. And then so our function is working well. Okay, if you store this in a database, this is the information you'll be able to store. And obviously, as we build our blockchain along, we're going to include the SQL database and install this. But at least now we know that this is how a block looks like. So in the next lecture, we're going to start building more into this blockchain functionality regarding transactions and so forth. because there's a lot that goes into the blockchain class, not just creating the Genesis block. Obviously, after creating Genesis block, there is going to be the mining function where you actually now create any block with the previous block before it. Okay, so we will do that in the next lecture. So now we have successfully created our Genesis block of the blockchain. I'm going to just remove this for now, and the print part, it's not necessary. We've demonstrated that the block gets generated, properly using this function. What I want to do next is to start working on the data that goes into the block, because after the Genesis block, you have to create the second block. And before we can do that, we need to generate transactions. And let's look at what we learned when we were going through the theory of blockchain. The way transactions work is that you'll have your blockchain where all the blocks get added, and then you have users of the system, and users will have their private key and their public key, and these users will generate transactions and sign the transactions with their keys, and the transaction gets sent with a signature, and then the blockchain would have to verify the signature of that transaction before the new transaction gets added into the blockchain, and all of this is done using what we call our elliptic curve cryptography. So we have already, Python has a library that has modeled this elliptic curve cryptography, and that library is this, I think I have it on the other side, is this fast ECDSA. Okay, so it's fast electric curve, DSA, I don't know what everything stands for, but basically this is a library we'll be using. And from here, we'll be able to import the curve that we're working with, the ECDSA and the keys, all right? So we'll be using these to generate our elliptic curves and our private and public keys, and then the same to generate the signatures and signing of the signature and verifying of the signature. We'll be using this library. So we don't have to do the math ourselves. So it's quite simplified approach, but you still have to understand the concept of what the libraries are doing. If you had to write the libraries from scratch, it would take a long time. Thank God somebody has done it for us in Python, and we're just going to use that, okay? So I've written some functions here, and the first thing that we want to do is you need to first of all generate a private key. So the process, the way it works, you got two keys. You start with a private key, and the private key is the one that belongs to the user. And then the private key is just one. Each account can have only one private key. But one private key can generate multiple public keys. But a public key is always associated with its corresponding private key. All right? And both the public key and the private key are used to generate a signature. Okay? It'll be better when I'm demonstrating to you in practice. So I've written some of this code here, and I'm just going to copy it and use it. So the function to generate a private key is this one over there. So let me copy that one, okay? And I'm gonna go to account, and I'm just going to say class account, not class account. Okay, so how do you write that? Okay, class account, like that, okay? And then dev. Okay, let me just copy that dev like that. Okay, so we're going to have a function that generates a private key, and that private key is you will use keys. You use this library from the factors library and generate private key. That's a function within the library, and then we will use the curve and the 256K encryption to generate your private key. Okay, and then I'm going to delete that, and then I'm just going to say return private key. Okay, and then what I will do here is I will also just quickly do a function for the public key, because once we have the private key, we might as well do the public key as well. Okay, so let's generate the public key. Okay, to generate the public key, you need the private key. Okay. And then the private key gets added into, use the keys, get public key from the private key and the curve, and then you can get the public key. Okay, so this one returns the private key. Okay, so let's write these functions exactly the same. Okay, so let's say in here the public key is equals to all of this. Okay. The public key is equals to all of that, and then you return the public key. It's exactly the same thing, because so that we have it in a standard way, you can see exactly what we're doing. So in this specific case, we are generating the private key, okay, and then we are returning it, and then here we're generating the public key, but we are generating it from the private key. To generate the private key, you don't need anything. Okay, so we're gonna test this out very quickly, and we're gonna say our account is equals to account. Okay, like that. And then we're gonna say public key is equals to account dot generate public key, private key. Okay, so let's make this PVT so that we know what we're doing. Okay, so PVT is this account variable which is generated from the account class, and then from that account variable we want the function that generates the private key, which is this function, and it doesn't take in any variables, it just works like that. Okay, then we'll have the PVT, then the public key, okay, PUBK will be equals to account dot generate the public key. All right, so account is the same account variable that comes from the account class times generate the public key with this function, and then it will take on the private key as a variable. So we need to enter the PVT in there. Okay, so we just want to sort of view it, and then we'll say, you know, let's just say print, okay, public key, the private key, the private key. Let's see what it will look like. The private key is print the PVT. All right, print the public key. All right, print PUBK. PUBK. This one, PUBK. Okay, we want to print that. Get the spelling right. So we've got the public key is the what, the private key is what. Okay, so we're just testing this as we go along, that our functions have you know, sort of downloaded properly. And let's do what we normally do here, which is push this git add. All right, checking the keys. That's done. Okay, so once you run it in the function that we need to run now is Python, no longer blockchain.py, because we've written this in a different function, in the different file account.py. So we're just going to run Python account.py. Okay, let's try that. Okay, account is not defined. All right. So there's something wrong with the spelling there. Okay, so this is account, should be the same as account there, should be the same as account there. So there was just a bit of a spelling error there. That's all right. We're just gonna quickly do this again. Right. So the private key is, this is our private key. This long number there, that's our private key. The public key is, it's got an X and it's got a Y on curve 6P261. K1. Okay, so everything is working accordingly. We now have our private key and we have our public key. So we're going to write a function that then allows us to sign a transaction using a public key and a private key and a generated signature, and then from the account, a class. So if we go here, we have a couple of functions. Okay, we've got a function for getting the signature, and then we've got a function for creating the transaction. So let's start with the creating the transaction, because we need to start with that before we can get the signature. So there's a couple of things you need in the account class. You need to generate the keys, and then you need to be able to sign a transaction, and then generate a transaction. Okay, so let's paste that function, then I'll explain it to you. Okay, so the first thing we do is we get a transaction ID, okay, and we just use that UUID, which is like a unique identifier, UUID variable to give us a transaction ID. Okay, so it will just be a random number, a random generated number. And then after we do that, we create a timestamp, and I've shown you how to use datetime.datetime. So let's just go and just get this imported here as well, because it's not imported in here, so this won't work. And then I'll remove that datetime, so it's just datetime.now. Okay, the transaction is also going to be a dictionary. So there's two ways to write dictionaries. The way we did it here was differently. We wrote it like that, so you can see every sort of variable that we're adding into the dictionary. This is written slightly differently, but we can change that so that everything is sort of universal, or it looks the same. And if you're looking at this code later on, you understand that this is a dictionary. So the first thing you do is that you create it. You create that variable that's a dictionary, and then you say transaction, the transaction ID. Okay, so let's just put that in there. The transaction ID is equals to the transaction ID. Okay, and then the timestamp. Timestamp is equals to the timestamp, which is that timestamp that you've created over there. Okay, this timestamp here. Okay, the transaction ID is that one, the timestamp is that one. We're just sort of assigning them into the dictionary under those variables. And then the last one is the data. Okay, the transaction data. We don't know what that is. It is the data. It will come in when we are calling this function. Okay, so you can then remove that, and then you can just return the transaction. So what does this function do? This function, when you invoke it or when you call it, it creates a unique identifier for the transaction. This will help us to be able to to sort of relay transactions to their transactional ID. It gives it a timestamp when the transaction was created. I know there's a timestamp for the block, but the transaction also gets its own timestamp, because you might have multiple transactions in a block, and then you might want to know when each and every single transaction was created for that block. So we create IDs and timestamps for the transactions as well. And then after we do that, we create that dictionary object, and then we assign the variables, transaction ID, timestamp, and the data, but the data will come in there. We don't know what that data is yet. And then there's a function for creating a transaction. And then the last one is a function for signing the transaction. So let's just copy that and put it in here as well. And all right, so what happens here? You you have a couple of variables. I'll explain them later. This SHA256, you just use that curve, the ECDSA curve, to create it. So these variables, you just have to create them as they are. Just copy this code. It's a long, involved process to try and understand what they are all doing. But basically, you need these two variables, and then the signature itself is that you will go on the curve, and then you will invoke the function sign, and then you will enter the transaction, all right, and then the private key. Okay, so to sign the transaction, you only need the private key of the account that is creating that transaction. So if we created an account and we got our own private and public keys, okay, every time we create a transaction object, that transaction object is the one that goes in here. So this transaction is an object, okay? And once we create that transaction object, we just need that private key, which is the private key would have generated there, okay? And that's all you need, and the rest comes from the function itself. And then you sign that transaction, and then you return a signature, okay? So this works. I'm not sure that we need to test it, but perhaps what we can do is, yeah, just show you quickly, okay? So what I'm going to do is I'm going to, again, create the account variable, which is going to be that, all right? And then the functions that I had before would be the private key, okay? And the private key is going to be that account. So I'm going to copy it this time so I don't get the spelling wrong, okay? Generate private key. All right, and you don't need to generate the private key, you don't need to enter any other variable in there. Once we've done that, I want to create a transaction that says, I'm just going to call this text, a beautiful day, right? And call this the text that I'm going to include in my transaction. And then I'm going to then create, invoke this function, create a transaction, okay? Then I'm going to say the transaction is equals to the account, okay, that account over there. And and then from the account, we're going to invoke the function, create a transaction, right? And then we're going to create a transaction using the data, right? And the data that we're going to use is the text, right? So we're just creating a transaction for that text. So it's just going to give you a transaction ID and a timestamp. So once we have the transaction, we're going to sign that transaction, okay? So we're going to say the signature is equals to account, because these functions are inside a class. Every time you call them, you have to call that variable for that class. So we're going to say this is account get signature, all right, and then get signature, and you need to sort of include two variables, the transaction, which is this one here. This is the transaction, and then the private key is that private, okay? So this private key and that signature will be able to give us that private key and that transaction will give us the signature. And then, maybe you want to see what the signature looks like. So I'm going to say print this is the transaction. All right, so the transaction is print trans, and the signature is print signature, right? So we're going to print this trans, and then we're going to print this signature. All right, so let's save this and let's push it, and then let's see what it looks like. Right, so that's done. And we're just going to run that function Python account.py. So we have a bit of a problem. All right, find get signature. Signature is that value error message transaction ID timestamp data of type dictionary cannot be converted to byte. All right. Okay, so we've got to do something. Yeah, I know what's the problem. Okay, sorry. Okay, so we can't sign the dictionary. We can't sign this transaction like this. Okay, so what we need to do is, first of all, we need to create like an encoded string the same way we did when we were creating the hashes for the block. We need to create an encoded string for the transaction, and then sort the keys, and then we can sign it. Obviously, that makes sense. But this is fine because that this everything else is still fine. So I won't do that now. I will do that when we actually start creating transactions. But we'll do that in the future. So for now, this is our class for account, and then we're gonna continue some more and create more code for our blockchain and for our account, and then start working on creating actual transactions and start building towards getting the app that actually communicates with the blockchain. So for now, we don't have the database yet. So I know that whatever you're doing, whatever the blockchain, whatever we're doing now just disappears as soon as we stop running the program. Okay, that's fine because we're still putting together the building blocks. We're still putting together the building blocks. So bear with us. Let's follow along. We're going to do this step by step until we reach the end. Okay, so continuing, let's quickly correct the problem with this function. The problem here is that we are trying to pass a transaction as a Python dict object, and trying to sign a Python dict object, you need to have this as a string or an encoded string. So to do that, let's just have a look at our function here. I'm just going to copy that and create a new variable here that says transaction is equals to json.dumps. So let's import JSON as well up here. Okay, so transaction is equals to json.dump transaction instead of block. Okay, so transaction is equals to json.dump transaction, sort keys true. So this function we're creating in the meantime is going to be, let's call this variable so I don't confuse you, encoded transaction. So it's json.dumps transaction, sort keys is equals to true, and then you encode that. And then what you will do is that on the other side, instead of signing the transaction, you will sign the encoded transaction. Okay, so let me actually copy this as it is and paste it there so that I don't have an error in there. And then you use the private key, and you'll use the sec_p261, which is this function there. In fact, what you can do is that you can just X that and put it like that there. All right, and then X that there, just to simplify our code, and put it there. Okay, it will work either way, right? So and then we return the signature. Right, and then so the encoding is happening inside the signature function. And then the next thing I want to do is to come to the blockchain, and we're going to improve this code a little bit. So the first thing that we're going to do is we're going to init, right? And to init the block, to initiate the function, we're going to create a chain, and that chain will start with an empty, like an empty list or an empty array. And I will also initiate transactions, and that will also be an empty list. So this blockchain is always going to keep a record of the chain and all the transactions. And the way we will do this is that every time we get a transaction, we will send it to the blockchain, and then this list will just grow, list of transactions. And then when it reaches a certain point, this list of transactions will be added to the next block, and then we will mine a block, and then increase the chain, and then we will empty the list of transactions. So every time we mine a block, we'll empty the list of transactions, and then the transaction pool will now start growing. So imagine this as your transaction pool. It will grow until we mine a block, and then we will empty it, and then the chain will grow. But we'll manage all of this from the blockchain function. Okay, so that's the first thing we'll do. And so assume somebody sends us a transaction. The first, what we need to do with the transaction when we get sent a transaction is to verify the transaction signature. And if the signature is correct, then we will add it to the transaction pool. So we are going to write a function now that is going to, let's call this add a transaction. pool. All right, and they will supply us with a transaction object. All right, so they will supply us with a transaction, and we will be required to add it to the pool. All right, so what do we need to do to add a transaction to the pool? The first thing that we'll need to do is to verify the signature of the transaction. Remember, when we discussed here, when users create transactions, they send us the transaction, but before we can add it to the transaction pool, we need to verify the signature to make sure that it is coming from the correct account. The account that it's coming from is the account that has got the authority, and then second of all, the signature is correct and the data has not been tampered with. So we need to start verifying that. So to verify the transaction, I have a function here for verifying the signature. I'm just going to copy it, and then I will explain to you what it does. So this function actually is just the opposite of the signature function. It just does the opposite and verifies the signature. Okay, so you need the curve, and you need the signature, and then you need the string transaction. In this case, I'm actually going to change that and call this encoded. Okay, you need the encoded transaction, which is what we're going to send here. All right. Actually, we're not going to send the encoded transaction. We're going to just send the transaction and we'll encode it ourselves. Okay, so it needs the encoded transaction, and then it needs the public key. Okay, so we need to send the transaction with the public key. Okay, so it needs the public key, and then it needs a curve. So what we'll do is that we'll get a transaction variable here. Just going to create some space at the bottom here so that you can see what I'm doing. Okay. So we will get the transaction and we will encode it to get the encoded transaction. So we're going to do the exact same thing we did there, is that the encoded transaction is equals to JSON dumps, all of that. Okay. So let's just paste that there. The encoded transaction is JSON dumps. The transaction itself, we solve the keys and then we encode it. Okay. And that is going to be that encoded transaction that goes there. The signature is going to also come with it's also going to come with a bundle. So to add the transaction pool, we need the signature, we need the public key, we need the transaction. We verify the signature that it's valid, and if the signature is valid, then we will add the transaction to the pool. Okay, so we encode it. That's the encoded one. That's the signature. I'm thinking as I'm going along, and that's a public key that comes there, and that's the curve and whatever. So that means we need all of these variables here as well. So I'm just going to copy. Actually, let's just copy all of this and paste it there. And if we've duplicated anything, I'll just check that quickly. So that's not duplicated. Datetime is duplicated. UUID is duplicated. Hash label is duplicated, and JSON is duplicated. Okay. So that's the only one that's not duplicated. That's fine. Then we will, if the transaction is valid, okay, so this is going to give you a true or false, okay, answer. So we will say if is valid, right? If it's valid, we're going to self.transactions, which is this sort of array there. We're going to append the transaction, right? So if it's valid, we're going to add this transaction to the transaction pool, okay, and then the transaction pool is going to grow. So this is the function for adding transactions to the pool. We can't test all of this yet because we have to write all the functions, and then we'll come to the testing part when we create our Python Flask application to check a lot of things. Okay, so if you do this correctly, you are able to add transactions to the pool. But the second thing I want to do as well is when we're initiating the blockchain is to create the Genesis block, okay? So to finish this function, we then need to say self.chain which is this variable there, all right? Self.chain All right, append block. All right. So what this will do is that when you initiate your blockchain the first time, you will then have to run this Genesis function. So I'm going to say call this self.create Genesis block. Great. So when you initiate this blockchain, this function will be run automatically because it's now included in the initiation function of the blockchain class. It will do all of that when we've checked this works, and then it will solve the chain. It will append the block, and then we will now have one block in the chain, right? Then every time somebody sends us a transaction, we will first of all encode it. We will check if it's valid, and then if it's valid, we will add to the whatever. If it's not valid, I suppose we need to inform people, so we will return false. Okay, and in this case, let's just return to, so that people will know, whoever is calling this function will be able to know whether they get it up and down, whether it was successful or not. Okay, so that's it. We're going to continue now with actually writing a function for mining or creating a new block within our blockchain. So it's different from the first function. The first function here is just creating a Genesis block for a blockchain. Okay, this one here is adding transactions to the transaction pool. All right, and then the function we want to create now, just create some space there, is going to be similar to this one, except it's going to be called mining a new block. Okay, so I'm going to call it def mine a new block. And in order to mine a new block, we are going to need the transaction data, which is already stored in the blockchain. So we will not be passing that into the function, because we now created that function there that adds transactions to a transaction pool. So I suppose we will just take the transactions from the pool and add them to the block when we're mining it. Okay, so instead of passing it into the function. So anyway, we will add the variables as we go along. So let's think about this. What do we need to mine a new block? We need the timestamp, definitely, and the index, right? So let's just copy some of that. In fact, let's copy all of these. Let's just copy everything, and then we'll edit it as we go along, and I'll show you what's going to be different about mining a new block. We definitely need the time. Okay, we have a new block. The index is not going to be 1, because the index is going to be the current index of the blockchain right now, and that will depend on where you are when this function is called. But because we have the blockchain stored in our class, we will be able to get the chain and figure out what the index is currently. Okay, so I've just copied the function there, and I'll just paste it for you and show you what this function is doing. So the index, instead of being 1, will be the self chain. Okay, so we will go and look at, so we need to actually put self in here, right? So we'll go and look at the current chain plus 1. That is going to be the index of the new block. All right, the previous hash will be the chain's previous block. Okay, hash. So I've actually copied it there as well, and I'm just gonna copy that and paste it at the bottom there. And then the previous hash is no longer 00. We'll be able to go and have a look at the chain, because we already have the chain blocked and saved in our class. We'll look at the chain, we'll look at the previous block of the previous chain, which can be accessed that way. The self chain -1 is going to be the previous block currently in the chain, and then we just look for the variable called hash. Okay, which is what we called our current hash. I changed it to hash. So the hash variable of the previous chain -1 is going to be the previous hash of this current block. Okay, the nonce, we're going to leave it as 456. All right, let's just leave it as that. And then the data now is going to be the transaction pool, right? So we're going to remove that, and the data is going to be self.transactions, right? So these transactions that are stored in there, okay, it's going to be an array of transactions, and those array of transactions which have already been confirmed, because remember, before we added transactions to the transaction pool, we confirmed their signatures. So they are added into the transaction pool as confirmed transactions. So when we mine the block, we're just going to take everything that is in there and we're going to mine it like that, and it's going to be an array of transactions, okay? And so that's the data. And the timestamp is the same. The encoded block remains the same, and the new hash is hashlib, all of that, hex digest, and then the block is that, okay? So I will append the block, all right, and then we will also clear the transaction pool. We have to clear the transaction pool because once we mine all the transactions, we cannot leave the transactions in the pool to be mined again by somebody else. So we then append the current block, and this is how we mine a block. But there's something slightly not wrong, but there's something we still need to adjust with this, because currently we are keeping the nonce the same. And remember, the nonce we said is supposed to be a randomly generated number that is actually used to calculate the difficulty of mining. Not to calculate, but it's used to sort of add the difficulty of mining into the mining process, okay? What we need to do now is to add on the calculation of the nonce, which will introduce the mining difficulty into this whole mining process. And then this is why this type of blockchain is called proof of work. You're going to have to perform that calculation as many times as it takes and end up with the correct answer, and then only then can you leave the mining function block, and that whole process takes time. And I'm going to now write that function or that algorithm that does that. And before I write the algorithm, I just want to, maybe at the bottom here, just show you what I'm going to be doing with this algorithm. So the algorithm is going to do two things. It's going to do a couple of things. The first thing it's going to do is that we're going to calculate a hash for the block, right? We're going to calculate the hash for the block that we're currently mining. And then we're going to check that hash against some requirements. Okay? A hash is a randomly generated number. And every time it gets generated, we're going to say the first 1 or 2 or 3 or 4, sort of variables in that hash, we want them to be all zeros. Okay, so if it generates a hash and the first 4 elements are not zeros, then it's gonna calculate another one. And if it's not all zeros, it's gonna calculate another one. So it's gonna calculate until it ends up with the first 4 elements being all zeros. That whole process is going to take time, okay? And the more zeros you request at the beginning of the hash, the longer it's going to take to get to that hash number. And that's where we're going to introduce the difficulty, and that's where we're going to make this whole hashing or mining process take time, okay? We could just say time dot count, whatever, but we actually want the computer to work. We want it to perform some work, hence it's called proof of work. So we want it to run the function, to use resources and look for the hash that matches the hash that we want, okay? And you can choose 4 zeros, or you can say, I want it to have a 0x and a 0, and maybe we'll try with a couple of zeros, and then we'll change those requirements and sort of test how long it takes to meet those requirements. And that will help us calculate the sort of the mining period that we are going to be having between the blocks every time we mine a block, right? So we're going to check the hash against some requirements. In this specific case, we're going to say that the first 4 digits of the string must all be zeros, or maybe let's make it the first 3 digits. The first 3 digits must be all zeros, and then we will print that hash, and I'll show you that really the first 3 digits were 0. And if there's all zeros, then we get out of the function, and then we've mined a block. Okay, so let's write what I've just explained here in Python code. So what I'm going to do is that I'm going to write it up here. And I'm going to say, first of all, we're going to introduce a new variable, and we're going to call this variable mining. Let's call it mining, okay? And mining currently is false, right? And then we're going to say while mining is false. See why I love the Python language. It's just easy to work with. While mining is false, this is the part where we're going to create a loop. We're going to do this calculation until mining is true. So this loop is going to keep running until you break out of the loop with a true answer, okay? So while mining is false, okay, we take all of this, we encode the block. So while mining is false, we encode the block, and then we create a hash, a new hash signature, and then we're going to check that hash signature against our requirements, okay? And then we're going to say if the new hash, I think we said 3 digits, if the first 3 digits of the new hash is equals to 3 zeros, if the first 3 digits of the new hash is equals to 3 zeros, right, we're gonna say mining is true. We're gonna break out of that function, okay? Mining is true, and then we're gonna say if the mining is true, then everything just works as it is, and we break out of the function, and then we go away, okay? If it's not true, we're gonna say the block nonce, okay? So we're gonna do something to the nonce. We're gonna change the nonce to a different number, okay? So we can say the block nonce, we can just add a number because it's 456. We can just say now it's 457, 458, 459. So we can keep sort of adding a new number to the nonce to get where until we and recalculate. So we're gonna say the block nonce plus minus 1. Okay, so what it's going to do is just going to increment this variable. Whatever the number that was in there will be incremented. Will increment. Yeah. Actually, let me do it like this. Okay. Yeah, block nonce plus minus 1, right? Yeah, that's fine. And then we're going to, once we've done that, then we need to recalculate this whole thing. So we need to then, the encoded block, is now just, now the block will be different because the nonce is now different. Okay, then it's going to calculate a new hash. So it's going to keep doing this, all right, until it gets, the right hash. And then once it's finished, if it breaks out of this while loop, the block hash will now be the new hash. And then what I'm going to do is I'm just going to say print right, and then let's just delete that. Test this function, run it, and see what happens. Okay, obviously if there's errors, we'll pick it up when we're running it. So we're just gonna say blockchain is equals to blockchain. All right, blockchain dot mine a new block. Right, mine a new block. It doesn't require anything, but before I do that, actually I want to add a transaction to the pool, and actually, add a transaction to the pool. Encoded transaction is valid. Okay, I can't actually add a transaction without so yeah, so we're gonna run it with like an empty transaction box. That's fine, because it's gonna take a while to try and run that transaction function. We need to create a transaction on the account side. Okay, so and I just want to test this, so let's leave it. Okay, so blockchain is blockchain mine new block, and when we mine a new block, we should be able to go through this and print the block, and then I just want to check that the hash of the block will have 3 leading zeros in front of it. Okay, so let's save this. Blockchain.py. There we go. All right. And that was quick, right? So it printed the whole block, okay? And index is number 2 because when we initiated the block, we already added the first block. So this is the second block in the index. The previous hash would be this one. This is the hash of the previous block. We can't see it now, but I'll actually demonstrate that to you. The data is an empty array because there's nothing currently in the transaction pool. So the transaction pool is empty. Okay, the timestamp is the time now, and the hash, if you look at it, it's got 3 zeros. So it actually ran this until it got 3 zeros in front of the hash, and we didn't even notice it. So it ran this in a couple of seconds. So for you to actually make this take longer, you're gonna have to add more zeros. You can say like I want it to have, the more zeros you add, you actually increase this exponentially, or you can even be fancy and say, you want it to be like a 0 and x and a 0 and 2 zeros. Okay, this is going to be a little bit more fancy. Let's try that. This should take longer now to run, so you should go through this a couple of times. But instead of printing the block, actually, I want to print the chain, okay? So that I can show you that the chain actually has the genesis block and the second block. So let us print the blockchain dot chain. So what this will do is that it will print, okay, this class, which is the blockchain dot chain, and then as an array, and we'll be able to see 2 blocks in the chain after we've mined a new block. And the first 4, so this should be 4 actually, the first 4 variables or elements, or the first 4 digits of the new hash should have a 0x and 2 zeros. So this should take a bit longer. I don't know how long it will take. What we can do is that we can print the block.timestamp. Actually, we don't need to print the block.timestamp because that's going to be automatic. We can just do this. Okay. No, actually, it doesn't matter. Yeah, I'm not going to worry about how long it takes. We will see how long the function takes to run. We'll sort of feel it as we're waiting for it to run. And then print block chain dot chain. Right. It's taking some time. It's taking some time. All right, so 0x is 0 is going to take some time. It might even take some minutes. I might have to pause this video and restart it when it is finished calculating. I waited a full 10 minutes and it hadn't found a solution. So this was a little bit too difficult for it, but it just demonstrates how the proof of work and the sort of difficulties added into the whole mining process. So obviously finding a hash that starts with 0x0 was too difficult for this little laptop, or Ubuntu machine that's running. That is why with some of the Bitcoin miners, you'll have like huge computers which are crunching, the hash per second. That hash per second number, they are doing that many hashes every second until they find a hash that matches. That is where the computing comes in. So we obviously don't have a very huge hash per second, you know, computing power. If we try to put X's in there, it might never get an answer. So let's just work with numbers, okay? Because numbers are easier to sort of get to. But I want a little bit. It's still a difficult problem. So I'm gonna say the first four are zeros, and then I want a 9. Okay, and then it's 1, 2, 3, 4, 9. I still want it to be a little bit difficult. So it's the first 5 digits. It's 1, 2, 4 zeros and a 9, which makes it 5 digits, because I still want it to sort of work out. So the numbers should be easier to get to because there are fewer numbers in the alphabet. I mean, there are fewer numbers from 0 to 9 as compared to all the X's from 8 to 26, so this technically should be easier than 0x0. But let's see. We're going to save this, and then we are going to all right, so we're going to run this function, and I'm going to put on a timer here and time how long it takes. It wasn't that long. I hadn't even put on a timer yet. Okay, I was still trying to put on the timer, but you can see it took a bit of time, but not as long as trying with the X in there, because then the X is much complicated. But there we go. So the first thing it printed was we said print the blockchain chain. So this is the chain, okay? So you can see there, you can't read properly, but that's the beginning of the sort of the list, and then index 1, and then that's the previous hash of 0, the nonce of 456, and the timestamp and the hash of E003. That's the first block where there was no mining required, okay? And then index 2, the previous hash, that E003, this number here is exactly the same as that. So we're taking the hash from the previous block and we're working with that. And then the nonce is now 5. That means this computer went from 456 and kept adding another number until it reached this number. And this is when it was able to find this number combined with our data, was able to give it a hash that started with 4 zeros and a 9. Now you understand how proof of work works. And when they say, a computer has a hashing, has a sort of a hashing power of 1,000 hashes per second or terahash per second. Remember all of those things when you were looking at the mining speeds of certain mining rigs and all of that. That's really how it's calculated. It's how many hashes can you process, okay, per second. And the more hashes you can process per second, the more likely you're going to get to the answer that fits the answer. And the blockchain itself is the one that decides this number. Okay, so 009 is easy. Obviously, it didn't take a lot of hashes. It just took like a couple of thousand hashes. You don't need a huge computer. Even my laptop, even the Ubuntu machine was able to do it in just a few seconds. But the Bitcoin blockchain is huge, and we wanted to take, I think they calculated, they wanted it to be, to mine a new block every 10 minutes or so, a couple of minutes. And for it to do that, they calculated this hash difficulty accordingly, that a new block would only be produced every 10 minutes, but also depending on the data that's in the block and all of that. And that's why the mining rigs and everything, they just work harder and harder. And obviously, as computing power grows and computers are able to process it harder, the difficulty is just increased, so that we always produce about a block every 10 minutes. And that's what we aim for. In our case, because this is a testing block, we don't need to overwork our computers and have them hashing a whole lot. So I'm happy with leaving it, the first 5 being 009. It will give it a bit of a waiting period, but at least this demonstrates the whole concept I'm trying to show you of the mining difficulty and the proof of work. This is exactly what happens with the proof of work. This is the code behind the proof of work in its simplest terms. Okay? Welcome back to the course. In this lecture, we are going to test our blockchain a little bit more and have a look at the accounts, generating signature. We're going to create an account, sign it properly this time, add the transaction to the blockchain and add a new block, mine the transaction. We're going to test that everything works properly. So for us to do that, remember we have a new file called app.py. We're going to finally put that to use. And we're going to just import the classes that we already created in the other files and import them into app.py. So the first thing we're going to import is from account, import account. So what this line does over here is that it goes and it looks for the file name called account. And inside the file name called account, it will import this class called account. So, and you do the same thing for the blockchain, and then you initialize them in this file by saying, blockchain is equals to blockchain, account is equals to account, and then you can now invoke the functions inside those classes on this, a different file without writing it in the same file. Okay, I've already written down some equations, some functions, and I'm just going to take you through it now. What I've written down. The first thing we're going to do is to calculate the private key. If you recall, there is the function called generate private key inside the account class, and we're just going to call that function, and it doesn't take any variables. And then we will then calculate our public key from that private key. Remember, one private key can generate multiple public keys. And the first public key that we're going to generate, we're just going to generate that public key using the private key, and then we'll have both private and public key pair. After we've done that, we're going to create a fake transaction. We're just going to call it, oh, this is my first transaction on my blockchain. And then after that, we're going to assign that transaction from the account class as well, get signature, trans1 private key. Remember the last time we had an error signing a transaction because we were trying to sign the transaction as a Python dict object, and you cannot do that. You have to encode it first and sign it as an encoded string or just a normal string. But in our case, we actually want to rearrange the keys, sort the keys out, so that if we encode it on the other side when we are verifying the signature, we can follow the same pattern, and then we won't have issues with variables being rearranged. And then anybody else who's connecting, if like there's multiple nodes that are connected to our blockchain, and they see a transaction in the transaction pool and they want to confirm that transaction for themselves, they might use the same encoding method. Okay, and then so we will discuss and we'll put in our documentation, this is the method for encoding, and then everybody does it the same way so that the signatures will always match and we won't have an issue with the signatures, because it's very sensitive. Like I said, even the comma in the wrong place, the signatures will not match. So you have to at least rearrange it in the agreed format before you sign it. It's important, the order of the objects in the dict. Okay, then after you've done that, you will then add the transaction to the blockchain. Okay, now we're going to invoke or call the blockchain class, and under the blockchain class there is that function for adding we wrote this function, we've never tested it, so we're going to test it now. In this function, it adds a transaction to the pool. It takes the transaction, the public key, and the signature. Okay, I had a bit of an error here. I hadn't included the word self. So just put self in front. In every function under a class, the first variable has to be self. Okay, then you add self there, and then we also encode it using the same method of encoding, and then we check if the signature is valid by verifying the signature using our elliptic curve and the public key that we are given. And if this answer gives you a true or false, so it's like a Boolean response. So if it's true, then we're gonna say self.transactions append this transaction. We're gonna append it as it is. All right. And I think perhaps we need to include the keys when we append it in case somebody wants to check it in the future. All right. So maybe what we need to do is we're going to say transaction, because the transaction is a dict object, isn't it? Let's just have a look here. The transaction is not a dict object. If we go back here, the transaction, when we send it here, trans1, okay, so the transaction is not a dict object, okay? So the transaction is just a string in our case, okay? So we're just adding, append the transaction, so that's fine. I think we'll fix that in the future. We can still test it, and then if it's true, valid, we're gonna return true. and if it's not valid, we're going to return false. Okay, so let's run this and see if we return true. If we return true, the only thing it tells us is that we were able to verify the signature, and we didn't have the private key. We only had the signature and the public key, and we're able to verify it. Okay, so I'm going to save this, and I'm going to run this here and see what happens. So we're going to say git add, git commit. Right, while it's still doing that, let's just double check what we should be getting. It will print the answer that it gets, the response, and that response will be whatever we are, this response of this function. Okay, so we can go up here and run the function Python app.py. There you go. So check if the transaction was added to the pool, print true. So we are printing two different statements. The first one is just printing a string, and then the transaction was added to the pool. But if we, the way to really check that the transaction was added to the pool is to actually mine a block and print out the new chain like we did before. So let's do that now, okay? Now that we've added the transaction to the pool with the new, let's actually add two transactions, okay? So let's call, that's why I call this trans1 and trans2. So transaction added 1 is that. So I'm then just going to copy. I'm going to just copy this. And then I'm going to create a second transaction. And I'm going to say trans2 is account create. This is my second transaction on my blockchain. Yay. So we have two strings that we are adding. Right, and then we're going to create a brand new signature 2, and we're going to get signature trans2 with the private key. So the private key remains the same. You're the same person, you're using the same private key to sign your transaction, but the signature will be different because this is a different string. And then we're going to test this again. Transaction added 2 is blockchain, add transaction to the pool, and we're going to add transaction 2 and use the public key and signature 2. Okay, so we actually don't want to test this. We don't want to like look at the answers, so it doesn't matter. We can just say blockchain add, and it's just going to add it. So what we really want to look at here is we want to now mine the block. All right, so we have to say mine a new block. All right, and then we're going to try and print the chain. All right, so actually before we print the chain, let's print the blockchain. Actually, let's not do that. The transactions, all transactions, okay, is equals to blockchain dot transactions, right? And then I want to print all transactions. So we will see this as we go along. Right, and then let's just print a new line. Right, then after we do that, then we're going to mine our block. Let's copy that and then say blockchain mine a new block. And this mining a new block does not take any variables. It's just going to mine it based on the transaction that's in the blockchain. And then what I want to do is I want to print the new chain is shown below. Give it some space so I can see what this is printing. And then I want to print, let's actually just new chain is equals to blockchain dot chain. Just make sure blockchain dot chain. Blockchain.transactions is what we called it. Okay, so I want to print the new chain. Okay, so we're doing a couple of things here, and let's just hope this goes well and cross our fingers we haven't made any errors. But the logic definitely makes sense. We are, first of all, creating a new transaction, and then we are signing that transaction, and then we are adding it to the transaction pool, and then we're creating a second transaction, signing the second transaction, and adding it to the blockchain pool. So the pool should have two transactions, and then we go and we call those two transactions, all the transactions in the pool. We want to see them. Let's print them out and see what they look like, and then we call the blockchain and mine a new block. All right, so blockchain mine a new block doesn't really return anything. Okay, so let's just say here return to. Currently, it's not quite returning anything. So it's good practice to return something from every function, even if you just return true. Okay. But it won't give you an error if you don't return anything. And then once we do that, we then just mine the new block, and then we show the new block. We print it out, and then we see what it looks like on the terminal. So we're going to save everything, and then we're going to test it out. And if all goes well, we are good to go. Right, so we've pushed it, and then we're gonna run that function again. It's exactly the same function, so let's see what happens. Okay, so the first part is printing the new transaction pool. It's taking time before it prints the rest, because remember we're now doing that whole the proof of work. That's what's taking a couple of seconds. So the transaction pool, that's the first transaction ID, the timestamp for that, and the data is, this is my first transaction on the blockchain, and then there's a new transaction, so there's two of them, and then the second transaction ID is that, and the timestamp is that, and this data is, this is my second transaction on the blockchain, yay. And then after that, it took a bit of time after printing a new line, because it's doing the mining function. Remember, it's going to take a time. That's what we designed it to do. And after that, it says now it's going to print for us the new chain. The new chain now shows the previous hash, the nonce. This is the Genesis block. It will always have the same nonce. Every time we restart this blockchain, the Genesis block will always be that. And then it shows the timestamp, it shows the hash, and then it shows the second block with the previous hash being this 84. E2 should be the same as that one. And for as long as we keep the data the same, the hash will always be the same. But in this case, it won't, because the timestamp can never be the same. So even with the same data on the blockchain, if that data is created at a different timestamp, the hash is different. So this is the beauty and the power behind the blockchain, and how we're really able to control the quality and the integrity of the data that we are producing. Okay, then we have a look. Let's look at our transactions. This transaction should be exactly the same as the transactions that were printed above, but what I want to draw your attention to here again is the leading 3 zeros and 9. So each and every hash signature in our blockchain is always going to have 3 leading zeros and 9, and that's also another checking mechanism. If you have a blockchain and you've designed it to have that, you will know that every block on this chain is going to have the same leading number of zeros, and whatever you've decided the difficulty is going to look like. And every time you get data from the blockchain, you can check it yourself, hash it. If it doesn't give you that whatever's 9, then you know that something is wrong with the data. Again, the beauty of a blockchain. So there are very multiple levels of security that are built into a blockchain, and some of them are not even as obvious as you might think. But the genius that created blockchain, Satoshi Nakamoto, thought about all these things. He thought about the time, the hashes, the difficulty, how we're going to build over time. I mean, sometimes it just cracks my mind. Like, I've done this so many times, but every time I build a blockchain, when I go through the genius of how this whole system was designed, I mean, it's very simple when I explain it to you, but actually it's quite complex, and it's just quite genius, and genius is in the simplicity of tasks. So I just love the way the blockchain flows. And so now we're good. I'm happy with what we have here. The only thing this shows is that our functions are well written. Okay, we don't have errors in our calculations. We are now going to build an application. because we're not going to be able to type numbers in all the time and type data in. Data is going to come from someone, and so we're going to build a Flask application with endpoints that's going to now be taking data into our blockchain, and invoking certain functions. So we're going to be invoking these functions through endpoints in a Flask application, and that's how we're going to be sort of like talking to and dealing with our blockchain. Okay, welcome back. In this lecture, we're going to, as we discussed, start creating the Flask application of our blockchain. You might wonder, what does an application have to do with blockchain? We're going to create an application as a simple way to enable us to communicate with the blockchain. Because the blockchain is going to be sitting in a Python file somewhere, we need to be able to tell the blockchain, okay, or add transactions, for example, the way we're going to send transactions to that blockchain to tell it that now this is a transaction that you need to either add to the pool or do whatever you need to do with the transaction based on the rules of the blockchain. We have to find a way to communicate with that blockchain. So that communication method and the instructions we're going to give it to automate it, we're going to use a Flask endpoint URLs, and then have a sort of a web front end where we can actually input information on a front end, and then it will go from the front end to the back end via an endpoint. And then once that endpoint is invoked or called upon, then that the instruction will be sent to the blockchain, and then the blockchain will do whatever it is we require it to do. I'm sure there's many other ways you can do it, but this is the way we've chosen to do it in this course, and I think it's probably one of the easiest ones. I mean, if you have any suggestions, that let me know. But so we're gonna go through the process of quickly setting up a Flask application. Okay. Flask framework is something that's called a micro framework. It uses Python to develop web applications. That is a server-based web application. So if you think about a web application, think about it like a dynamic website. All right, so you would have a static website, which would just be an HTML page. Maybe it says, hi, my name is Bertha, and I put that on an HTML file. That's a static website, okay? But if I want to, sort of like interact, have dynamic information, dynamic data. I want to say, hey, my name is Beth. I put it in an input. I want it to print it back to me. I want to interact with it, add something to it. I want to make like a dynamic application that does things, which has a server at the back end that does some micro computations and sends me back forth what I need. You need to create a web application, and there are many ways to do web application, but because we're working on a Flask blockchain, a Python blockchain, we're going to use Flask because it also works with Python, and then they just all marry together. And but let me stop explaining and let me get into the coding. And I think as I'm coding, it will become clearer what we're trying to achieve here. So the first thing we're going to do is let me just take you through some just like overall high level things when it comes to creating a Flask application. This is the file structure that you need for a Flask application. It's standardized, and basically this is how it works. You can go through their documentation and you'll pretty much come up with the same conclusion. So I'm going to save you a bit of time and just tell you what you need to do. Okay, so you will have a root folder where everything is happening from. Assume this is where your application is going to be based. So on the root of the domain, you need to have a file that is called the app file, or you can call it anything you want, but basically this is where your Flask application is going to sit, and this is where we're going to be running the application from. And everything else we will be calling from this Flask application. So this is sort of like the center or the heart of our application. And this time I've chosen to separate the config.py file. Usually with normal Flask applications, you wouldn't have a config file. You would just create all the config data information inside of the app.py file, but I'm going to separate it, and I'll tell you why. Because I want to be able to, when I push these changes or include this in GitHub, I want to exclude the config file because it's going to have passwords and important information I don't want people to see. So when I sort of share this code with you guys at the end of the day, I'm just going to just the only thing I have to do is to delete my config file, and you guys build your own config file instead of me trying to go and find all the different elements inside of the app. Where did I put the password? Where did I put this? Where did I hide code? So the config file just makes things easier for me. I can just remove it from the rest of the code when I want to share the code with other people. So all the sensitive information I'll put in the config file. Then you need a folder that is called static. This is just how Flask works. Inside your static folder, you're going to include all your static files, like your CSS, your JavaScript, your images and your fonts. If you got font files, specialized font files, anything that is a static content for your website, you include in the static folder. And we'll get to that a bit later. And then you have what we call the templates folder, and in here you're going to include all your your actual HTML files. So these HTML files are different from the static files, because these ones are sort of like your library, your library files, your CSS library, your fonts library, whatever. But your HTML file is sort of like it's not dynamic, but it's a working file. You want to be putting your HTML code in there that defines what the website looks like. So let's get down to it. So there's two ways to do this. We can this is our our Atom file editor. You can create all these folder structures from here. So that's the first way of doing it. If you just right click at the top there at the root, and you just say new folder. Okay, so the new folder that we're going to create is going to be let's create the first one, the static. Come on, my hands are slow today. Static folder. And then you'll see there's nothing under the static folder, and then I can just create inside the static folder a new file, and I can just call that a new file. Actually, not a new file. Let me just change that, because our CSS and our HTML is most likely going to be inside folders. So I'm going to create a new folder in there, and I'm going to call that CSS folder. And then okay, so it didn't create it like that. So that's the first way of doing it, but I'm going to delete it because it's creating it like a document. And sometimes let's go delete this. Delete, and sometimes that's a problem you get when you're trying to create it from the from the code editor itself. So actually, a faster way of doing it is to create it from the shell. Okay, so let's see where we are now. So we are in our main directory. You can see this is the static folder that we just created. Okay, so what we can do, we can just go into the static folder. So you cd into static, and you'll see that inside the static folder there's nothing, and you can create all your folders in here. And the way you create your folders is just using mkdir, and then you can create the CSS folder, the JavaScript folder, the fonts folder, and the images folder, and I think that's all of it. CSS, JavaScript, fonts, images, and if there's anything else, I'll do it later. Then when you list it again, you'll see all the folders you've created are available now, and then you can cd out of there, and you can now create a new directory, the templates one. Okay, the templates directory, and you can run two commands at the same time by clicking and cd into templates. So this command is going to create a templates folder, and then it's going to cd into templates. Make sure the spelling is correct. Then you're going to find yourself inside the templates folder. And then when you create a file, you don't use mkdir, you use touch. So you can touch index.html. That's the first file I want to create. And then I want to create 404.html like that, and click enter. And then if you go back to your code editor, you will see all the folders I created there. I created static and all the folders underneath. Then I created templates, and then I created all the files under template. So we're just gonna go to the index.html file, and we're gonna just, if you're working from from Atom, you can just start typing HTML like that, and before you type the L, you'll see that green enter, and you can just click enter, and it will give you a basic sort of HTML structure for a document, and then you can type the stuff that you want in there. All right, but I'm going to use my specialized template, which helps me think. But it's similar, I've just added a couple of things here. The viewport, I've added the title. So the title here, we're gonna call this Scholar Blockchain. All right, and then we have some favor icon. We don't have it yet, but this is basically how you represent files in sort of Flask template format. And then you've got the body and a container. This is Scolo. Let's start building this school. Are you ready to learn some amazing things? I use this everywhere. So so basically that's your index file, right? So we're gonna go back to the app.py. So if you go back to our file structure, we've created a static and all the folders that go under static. All right. So that's the one there, and all the folders that go underneath there. Then we've gone and we've created the templates and index and 404.html. So these are the two files there. And then we need an app.py and a config.py. So let's go into our app.py there. And I've already pasted what you need in the app.py, but I'll take you through it. All right, so you need first of all to import the Flask library. All right, but before you can import the Flask library, you need to install it. So we're going to go through installing the library, and then we're going to import it. So assume it's already installed. We are importing it here, and then we're importing config. But importing config is actually importing the config file, which is this config file. It's in the same root directory, so you can just type import config. It's going to find it in the root directory. It's called config, and then it will be filed there. So anything that comes out of config, you can just call it that way. And then this is what you need to, this is a function you need to write for the 404 template. So what this does in Flask is that if there's a web page it cannot find, it just displays the 404 template. So this is a nice way of controlling the 404 page that gets displayed, so that you don't have the standard 404 that's not designed. Then you can go and work on your HTML 404 template and design it the way that you want, so you can share the message that you want and you can look like you've taken care of your 404. So I always have this standard on my Flask websites templates, so that that gets displayed that way. And then then you'll just say Flask is app is Flask app config. So now we are sort of importing the config from the config file. So the app.config is we're going to import it from an object inside the config file. So let's have a look at what is inside the config file. This is basically the arrangement that you need inside the config file. All right. The first thing we are defining is the debug or testing. We are saying no, we are not testing, but we are debugging, so that it can be in the debug mode. And then we're just going to create a class. You can call this any class that you want, but we're going to define all our sort of like config elements under the under this object. So the first one is really the secret key. That's important. That's the first one that you define when you do a Flask application, and it can be anything. I always recommend a long multiple letters, words, something that's not easy to guess, because if people can guess your secret key of your Flask application, they can do a lot of harm and damage to your application, without your permission. If they want to hack you, they can hack you easily. So this key needs to be very, very secret, because it's used to sort of encode a lot of, or lock a lot of things, to make your application much more secure. So do not use this code that I have here, super secret key. You're gonna have your own sort of super secret password that's long at the same time. And then we're just going to decide that the config we're going to use is development. And the way I wrote it like this is, let's say you had like different types of environments. I know it's hard to understand now, but I want you to do things right the first time. So if you have the right structure, it's easier to work with in the future. So if you have different environments, like for example, if I'm developing from my own computer here, from my Apple MacBook, and I test somewhere else on a Linux computer, and I'm running it, the code, on a VPS that's sitting in a different computer, I might have different configurations. So I might have this development configuration, and then I might have another configuration that says, for example, let me call this the Apple configuration, or the home configuration, home Apple configuration. And then I'll have different, for example, where you're going to store your images. There's a lot of things going to go into this config file, into this config object, and you'll see why you might want to have different configuration elements. So you would have home Apple configuration, development configuration, your server configuration, whatever. And then underneath here, under the config object down here, you would then specify and list all of them, that this one talks to that object, the next one. So I would have another one, for example, that I would say home. Let's say I call this home, and then I would say home, it talks to this one. So I'm just going to copy that so I don't get the spelling wrong, and paste it there. So for example, then I have different options for the configurations, and if I had different keys, different secrets, I could do it like that. And then on the app file, when I import the configuration, I have to tell it which configuration to import, the development, the home one, or the whatever. And then I can change it here, and it will pick whichever the object that I've selected there. So for now, we're going to work with the development config, but I'm going to leave that home open so that you know how to create multiple options if you want to have multiple configs. So we've selected that one, and then we're going to register the handler. And after that, I'm going to say the first root that we're going to have, which is the first root is going to be the root of our filing structure. It's going to be the index file, and so we just define it as index and a render template index.html. So it's going to find under the templates a file that's called index.html. So if you've used this configuration structure exactly, you don't have to change this at all. And I like to put low because this is very dangerous. Don't always do it. But I under development I won't do it like that. But I mean under production. But to simplify things when I'm developing, then I don't have to remember which variables I need to send forward to the front end. So yeah, basically, let's do it like that. And then you run on this port 888 So our app, it should be ready to run. If we run this Python program, it will open a port 8888 and it will serve this application there. And when it serves that application root, home root, it will serve us the index.html file, and the index.html file is this one here that it says this is Scolo. So I'm going to save all of this, and then I'm going to pause the video, I'm going to push the changes, and then we're going to check what our website looks like. If at least we've got the Flask set up correctly, then we can start creating routes to start talking to our blockchain via the Flask routes. And you'll see what I was trying to say there was, for example, you might have a route that says, hash block whatever, and then you put all the hashing block functions in here, and then every time you call this route, then it does what you want it to do. For example, that is why I created the Flask application, to help us write functions to talk to the blockchain, but not have to type it manually every time. The way I was typing it when I was sort of showing it to you, we will now be able to talk to our blockchain via this method. And because our blockchain is now a file that's written here, we can just actually import it at the top there, so I'm just gonna go have a look here at this here, and I just don't want to retype this, and I'm gonna just copy it like that and go to app.py, and you'll see there from account import account, and from blockchain import a blockchain, and then we can start talking to these classes in our Flask application. Welcome back. So what we have done now is we have pushed all the changes to our virtual machine. Remember, we are working and running on our program on our virtual machine. So we've pushed all the changes, and I've added a new file called .gitignore. Okay, so .gitignore. Let me look for it. There it is. And in there, I've told it to ignore the file called config.py, and you see it's grayed out there to show me that it's going to be ignored. So every time I push changes to my VPS machine, that file should not be there. Let me have a look there. Config.py, it's actually there. So let me list it. It's there. So I suppose I should have done this before, because I had this file here all along. So let me just do this nano and just open this file and see what's inside. Yeah, everything is in here. All right. So I suppose you need to put in your gitignore file. You need to put in the gitignore at the beginning, because this file was already there. It was already being pushed all along. It's a file I created a long time ago. Then I created the gitignore and added it. But technically, before you push anything the first time around, you put your gitignore file, then you put that config file in there, and then it will not include it every time it's pushed. But anyway, for now it doesn't matter. I'm gonna change this password anyway, and this is just for educational purposes. Then once you push the changes, you then activate our virtual environment. If you remember, we're working off a Python virtual environment, the blockchain ENV. So what you need to do to activate that is source blockchain ENV bin activate, and then you will see it activated on the other side. So everything we are doing now, we are executing all our code right now under our virtual environment, which has all the Python libraries that we've installed inside of the virtual environment. So the virtual environment carries all our Python libraries and separates them from other programs. If we were running another program, we don't have to use a different, like the Python libraries are sort of what do you call it, separated and sort of enclosed within the virtual environment. Now what we need to do now, because we've included a new libraries at the top there, Flask, we need to install Flask inside this virtual environment. So the way you do that, you just say pip install Flask. It's going to go collect Flask and it's going to install it. Okay, requirement already satisfied, so Flask is already installed. So if you had not installed it, it would go and install it in here. And I think we need to also install Okay, no, I think then that's done. So now let's run our program. So remember in the past we used to run, okay, no, we actually can just still run Python. Okay, before you run this, if you followed the proper method of installing of setting up your VPS the first time, you would have a firewall. All right, you will have a firewall that is activated on all the ports, and you sort of remove the firewall as you need the ports, and then when you finish using the firewall, the port, then you close the firewall. You close that port again by activating the firewall on that port. So this is just good practice when you have a VPS, because this machine is sitting in the cloud. Technically, anybody who has my IP address can access this virtual machine. So you need to close up all your ports. Your firewall must shut all the ports down and only open up the ports that you're using only for the time you're using them. When you finish using them, you close them again. So you would have already UFW installed in this virtual environment, and in this VPS or cloud machine, and you access it via UFW. So you would just run this command sudo UFW allow. I think we're going to be using port 888, and I think I've already done this now, so it's going to show you that it's satisfied. I'm just gonna put in my password there, and it will say skipping rule. I just did it before I started the video, but in case you had not done it, then this is when you open up port 888, so that it allows you to actually access your application via the port that the application is going to be on, and everything else currently should be under UFW. If it's not, please go and Google how to set up a firewall on Ubuntu VPS machine, and whatever the Ubuntu is, 16, 18, 20, and then set up your firewall and close up all the ports. Only leave the ports that you need open. Now we can actually run our application. Okay, so Python app.py. Let's run it and see. All right, so no errors, everything is running. We just need to go to sort of our a website, and then go to this our IP. Let me just see where I've written it down. I think I've written it down somewhere. So this is our IP address. I'm just going to go to let me see. Yeah, let me go in there. Right, so you just go to HTTP, right, not S, and just put in that IP of yours, and then the port, which is 8888. Yeah, and let's see. So then there's your website. This is Scolo. Let's start building this, whatever. So this is basically the HTML that you've written here. This is Scolo, wara wara. So everything is working fine from the Flask perspective. You see, we still have not secure there because we're not running this on HTTPS, but obviously we're just developing. When we finish running and building the app, we will put up our SSL certificate later on, and I'll show you how to do that. So for now, I think this is good. So in the next lecture, we're going to work on actually starting to set up the roots and starting to sort of invoke our functions on the blockchain. So I'm not going to worry currently about styling and CSS for now, okay? For now, we're just going to focus on the server side sort of coding of the blockchain and invoking the sort of the functions via the roots on this page, and whatever is displayed on the front end is not important, okay? So yeah. So we've come a bit of a way in this blockchain development process. We are busy developing a actual blockchain from scratch using a Python. And I thought this is probably a good time to reflect as to what we're doing, so that we can see where we're going and where we come from so far. And we can put all of this in a big picture to help you understand exactly how the concepts are coming together in this program that we're putting together to actually build this blockchain. Now, let's look at all the code we've written so far. So we just finished completing that Flask application, and I explained to you that this Flask application is going to be how we communicate with the blockchain, right? But I'm going to explain this a little bit more. This is where we started. We started by developing this Python program here, where we wrote a lot of blockchain functions, as I had explained what a blockchain is to you, how we're going to create our Genesis block, how we're going to create and add transactions to the block, and I showed you how we are going to be verifying these transactions using the signature before we can add this transaction to a block. I've taken you through creating this function where we are mining a new block, and this is how we're sort of adding like all the transactions together to actually mine a block. And I've taken you through the whole concept of proof of work and what we're working here. And then we went and we created what we called an account class as well, where we were able to create the private key and the public key that's going to be used in this blockchain of ours when we are mining blocks. When we are mining blocks to verify transactions, to create transactions. So now we've done sort of a lot of segmented sort of coding here and there, and I want to just spend time to explain how all of this comes together in the actual blockchain. Now that we've written these functions, this is where they fit. Remember what I said to you, a blockchain is a chain of blocks, but a blockchain is actually just a database. It's a database that is distributed, okay? So it's a distributed ledger or a distributed database that is distributed across multiple computers or multiple nodes in a way. So we are writing the code here that's going to manage how this data is going to be controlled and how we ensure the integrity of the data within one node of the blockchain. So every code, the whole code that we're writing here is going to go into this server program, and it's going to manage how the data is entered into the blockchain. I've written or shown you how to write the Flask application here, and I explained the Flask application is going to be how the users of the blockchain communicate with the blockchain. So consider the users are like me and you outside, and we want to now record a new transaction. We are going to use the Flask application and create a route on the Flask application that will allow us to say to the blockchain, please, this is the new data that you should be adding, and then I'll provide my keys or whatever, whichever way I have access to be able to provide that data, and then that that root will then talk to the blockchain and then verify signatures, whatever it's going to do, and we're going to write all of that functions. But that is why we created the app. The app is going to be sort of the interface between the users on the outside talking to the server on the inside, right? Now, this whole application that we're going to build, the Python application, is going to sit on one computer. Okay, I've taken you through the process of developing this VPS system on one computer, and this computer is going to be one node just on the blockchain, which means this computer needs to talk to other computers on the same blockchain system. So after we finish with this whole development process, we are going to have multiple nodes that are going to be sitting on multiple VPS machines or VPS computers or home computers, whatever. As long as that computer is connected to the internet, we will be able to take this program that we're writing here and duplicate this program on all these different computers, and they will be running the same program. So anybody on a different computer will have the same arrangement as this, meaning that a user will be able to submit transactions to that computer, and that computer will be able to verify those transactions, and then it will add those transactions to the blockchain. But then when it adds them to the blockchain on this computer, there has to be a way that then this computer will be able to compare this blockchain that it has with other blockchains that it receives from other computers which are on the same network. So in this one network, we're going to have more than one computer that is going to be keeping track of the same database or the same blockchain. And we need to write a system that will allow for a peer-to-peer communication between the different computers and maintaining that the blockchain data remains the same through all of that, right? I know it's a bit confusing now, but I have to start putting the big picture for you to help you understand how all of this is going to come together to build an actual blockchain. If I was just building a data system of a chain of blocks in just one computer, that is not a complete blockchain. A complete blockchain includes multiple servers, multiple nodes, multiple servers. Hence, I call this a distributed. So the data is distributed across these multiple servers, but somehow due to the computing and the programming, we are able to maintain the integrity of the data between these different servers to make sure that the data remains the same. So that's what we're doing. So far, we've only built data on one computer. This is one server, one VPS machine where we have built all our code. We're going to need something. Before we can continue, we're going to need a database. All right, so that's what we're going to do next. The next lecture is going to be focused on us building a database. Why do we need a database? Because we're going to need a place to store this information that's coming in. So let's say I'm a new node and I enter the blockchain network, right? When I enter the blockchain network, I'm going to request the first time I'm going to say, guys, please give me the latest blockchain that you have that has been verified. They're going to send me that chain that has been verified. I have to store that chain somewhere. So I'm going to store it in my database, and I'm going to keep my own version of the blockchain. And then I'm going to run my front end application and allow new people to be able to submit transactions through this front end or whatever. Or I'm going to be able to submit my own transactions, whether I am just one computer that can submit transactions as one. I think maybe we'll simplify it and just make this one wallet instead of having multiple wallets within one server. So we'll have like just one wallet which has one private and public key that is kept in here, and then each and every single node will have a private and a public key, and then all the transactions will have to be managed through only one person who has access to that computer. So assuming that I have access to this computer, then I have the right to use the public and the private key of that computer. We're going to simplify the process, but in reality it's going to be a little bit more complex than that. But at least to show you the principles, we'll simplify it like that and just have one public private key set for one node, and then one node has only access to do certain things on the whatever. But I will still need a way to talk to add information. Even if I'm the only person who can access adding data to the blockchain, I need a way. I still need like the front end to be able to do it. So the front end stays, and so we need a database. So we're gonna build a database that when I get a chain, I can compute and make sure that this chain is correct, and then I can save this chain in my database. And then as I add transactions, I will add transactions to my chain on my database, and as soon as a new block has been mined, if I'm the one mining a block of my chain, I need to then communicate that data of that block to everybody else on the network so that everybody else can update their blockchains to include the new chain that the new block that I've just mined, for example. So, or if there's a new transaction I'm adding, we're going to have to add that transaction to the transaction pool of the entire network, right? And when a block is mined, whoever mines the block has to then communicate that they have mined a block to everybody so that everybody can update their chain to have the latest chain, so that all the computers on this network are always working off the latest chain. And if for some reason somebody is manipulating data, let's say one node is not playing along and they want to sort of add their own stuff that's not there, and they somehow put data that doesn't match up onto the blockchain, they can only manipulate their own transactions provided those transactions have not yet been mined into a block. But once a block has been mined, they can never update that data on that block, because if that block changes, the chain they have will not match the chain that I've got, and I'll be able to know that your chain is not the correct one. But if two of us have conflicting chains, we will have other nodes on the network to compare with, right? And then it's going to be like a voting thing, like if because you cannot manipulate all the nodes all at the same time. So the majority, the ones with the most, where the chains agree, we're gonna agree that is the chain that we're working with going forward. So that's basically how sort of a blockchain network works in managing data integrity, is that you have multiple nodes all connected together and they're all managing the same database. If the database it changes and we add new information on the database, we broadcast this information to everybody, so everybody will get access to the new data that has been added to the block, and then everyone will be able to update their own chain in their own database and keep the latest records. And if I just want to inquire with information on the blockchain. I don't have to every time go to the network. I can just check my own blockchain, because when the blockchain changes and then there's a new block, I will get updated, and I will always have the latest blockchain inside of my database. Does that make a little bit more sense? It will make more sense as we go along. So there's a couple of things we're still going to do going forward. The next lecture we're going to do is we're going to set up this database and set up the app, or we've already set up the app. But set up the app to now at least give us information of the database, but we'll still be working off just one system. And then after that, when we're coming towards the end of this whole course, we are going to now go into the peer-to-peer network, where we're going to go into now what happens when we have multiple nodes in the same network. How do we now incorporate that? And I'm going to code for you an actual peer-to-peer network, and we will test it with multiple VPSs that are now talking together and making sure that they're keeping the same blockchain constant between all of them. So this is going to get exciting. I thought this was important to give you a nice bit overview. So let's continue now with building our database.